Hey guys, tonight we are going to travel back 66 million years to stand on the shores of a lost world and witness its final, terrifying hour. Imagine, we are standing in a world drenched in deep time. The continents beneath your feet are in the wrong places. The air you're breathing is thick, soupy, and filled with the scent of strange flowers and damp earth. This is the late Cretaceous period, the magnificent long afternoon of the age of dinosaurs. But in this alien landscape, a familiar drama is playing out. Before you, a herd of living mountains, creatures of immense power and surprising grace, move through a forest of giant ferns. They are the masters of this world, the culmination of an evolutionary dynasty that has ruled the Earth for an almost unimaginable length of time. For 165 million years, they have conquered, evolved, and diversified into an astonishing array of forms, filling every ecological niche a creature of flesh and bone could possibly occupy. They are the undisputed kings of the planet. So how could such a dynasty, so absolute and enduring, vanish in a geological heartbeat? What force could possibly erase a world? And what does their end tell us about our own beginning? Tonight, thanks to a mountain of fossil evidence and incredible scientific deduction, we are going to witness that final day, that final hour, and the dawn of the world that followed. Frankly, if you were dropped here without a time machine, the air alone might be a problem. And that's before something the size of a bus decides you look like an interesting snack. So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. That small click sends a big signal to the algorithm. That long-form, serious educational content still matters. And to me, it's an incredibly meaningful show of support. Thank you so much for helping keep this channel going strong. It always fascinates me to see where you're all tuning in from. Let me know in the comments where you are in the world and what time it is for you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The Earth you're standing on feels fundamentally different. It's a hothouse planet, so warm that there are no polar ice caps, and forests thrive in regions that, in our time, would be the frozen landscapes of Antarctica. The great supercontinents of the past have fractured, but the world map would still be unrecognizable. North America is split by a vast inland sea, and India is a lonely island drifting north towards an appointment with Asia that is still millions of years in the future. The very air is thicker, heavier. Scholars still argue whether the oxygen content was higher than our modern 21%, but it certainly feels rich and potent in your lungs, carrying the smells of wet soil, rotting wood, and the heavy perfume of early flowering plants like magnolias. You are in the heart of what will one day be called the Hell Creek Formation, a stretch of land in North America that will, in our distant future, become one of the richest fossil beds on the planet. The ground is soft beneath your feet, a carpet of fallen leaves and damp moss. Giant ferns curl up around your knees, and towering conifers create a dense canopy that dapples the light. The sounds are a symphony of the unfamiliar, the buzzing of insects the size of your hand, the croak of an unseen amphibian, and a constant, low rustle in the undergrowth that tells you this world is very, very much alive. Then you see them, and the sheer scale of life here truly sinks in. Through the trees, a herd of Triceratops horridus is on the move. They are magnificent, each one a 9-ton fortress of muscle and bone. Their heads are immense, accounting for nearly a third of their body length, dominated by a formidable shield of solid bone that fans out from the back of their skull. 3 sharp horns jut forward, 2 long ones over the eyes, and a shorter, powerful one on the nose. You watch as one of them uses its powerful, parrot-like beak to snap a thick, cycad branch, chewing the tough plant matter with rows of shearing teeth hidden in its cheeks. Its skin isn't smooth, but a mosaic of large, bumpy scales, like a leathery, pebbled hide. As a mainstream historical fact, their fossils are among the most common found from the very end of this era, telling us they were a tremendously successful species, the bison of their day. As the bull of the herd turns its head, you notice the intricate network of blood vessels across its massive frill. This has led to a fascinating, though unproven, tidbit of a theory that the frill wasn't just for defense. Perhaps it was a biological billboard, capable of flushing with vibrant color for mating displays or to intimidate rivals, a silent, dramatic form of communication. For a moment, you can almost picture it, a wave of crimson and blue washing over the bone shield. A sudden movement nearby breaks the spell. A smaller, bipedal dinosaur, maybe a Tektites, darts out from behind a fern and scurries away into the forest, its long tail held stiff for balance. Its sudden flight reminds you that this ecosystem is a complex web, not just a stage for giants. In the leaf litter and hidden in burrows are the quiet players of this world, lizards, snakes, and the small, furry mammals that are our own distant, humble ancestors. For now, they live in the shadows, their time not yet come. For now, this is a world of titans, stable and timeless, utterly unaware that its time is about to run out. The peaceful grazing scene shatters in an instant. The heads of the Triceratops herd snap up in unison, their great frills forming a wall of bone and horn. The air, moments ago filled with the sounds of chewing and shuffling, becomes tense with a new, heavy silence. Then you feel it, more than you hear it at first. A deep, resonating thump that vibrates through the soles of your feet and into your chest. Another thump, closer this time, shaking the ferns and sending a flock of small, primitive birds scattering from the canopy. Something immense is approaching. The herd instinctively shifts, forming a protective circle around the younger animals, their horns pointing outwards. They know this sound. It is the sound of the king. He emerges from the dense wall of conifers, and the sight of him is both terrifying and magnificent. A fully grown Tyrannosaurus rex. He is larger than you could have possibly imagined, nearly 40 feet from his snout to the tip of his long, balancing tail, with a head the size of a refrigerator. His body is a monument to predatory perfection, a 7-ton engine of muscle and bone. His powerful legs, rippling with muscle, end in 3-toed feet, each toe tipped with a wicked, curved talon. His hide is a patchwork of scales, some small and pebbled, others larger and more reptilian, the color a mottled, earthy camouflage of browns and greens. His gaze is what truly freezes you. Unlike many other dinosaurs, his eyes face forward, giving him superb binocular vision, the ability to judge depth and distance with lethal accuracy. You can see the intelligence there, the cold, calculating mind of an apex predator. As he moves closer, you notice his ridiculously small arms, each with 2 tiny clawed fingers. For a creature of such overwhelming power, they seem like a comical afterthought. Historians still argue whether these arms were truly useless, vestigial limbs on their way out, or if they served a specific purpose. Were they used to slash at close-range prey, to help the massive animal push itself up from a resting position, or perhaps even to grip a mate. The debate remains one of paleontology's most enduring puzzles. The T-Rex lets out a low rumble, a sound that feels like it's coming from the depths of the earth, and opens its massive jaws. You see rows of serrated teeth, each one the size and shape of a railroad spike, designed not for slicing but for crushing bone. For a long time, a popular theory was that T-Rex had a septic bite, that bits of rotting flesh caught between its teeth would cultivate a cocktail of deadly bacteria, ensuring that even if a wounded animal escaped, it would soon die of infection. The standoff is a masterclass in ancient tension. The T-Rex circles the herd slowly, its massive head low, yellow eyes scanning for any sign of weakness. A juvenile, an old or injured individual. The Triceratops bulls watch his every move, stamping their feet and letting out low, guttural bellows. Their horns are not for show. They are deadly weapons. This is the great drama of the late Cretaceous, a dance between armor and teeth, power and defense, that has played out countless times across this landscape. It is the very definition of a balanced ecosystem, and we have the scientific evidence to prove it. Paleontologists have unearthed Triceratops fossils bearing the unmistakable marks of T-Rex teeth. Crucially, some of these bone injuries show signs of healing, a clear indication that the Triceratops not only fought its attacker, but survived the encounter and lived for years afterward. This wasn't a one-sided slaughter, it was a genuine contest of titans. And while this particular drama unfolds in North America, you must understand that this is a global stage. Pull your focus away for a moment and picture the rest of this vibrant world. Far to the south, in what will become Argentina, herds of the truly colossal Argentinosaurus lumber through the forests, their long necks reaching for the highest branches. These were the largest land animals to have ever lived, so massive that it's believed no single predator could bring down a healthy adult. On the continent of Africa, a different kind of monster ruled the waterways, the immense sail-backed Spinosaurus, an expert aquatic hunter. The planet is alive, a complex, thriving biosphere, filled from pole to pole with creatures of every shape and size. The world is in perfect dynamic equilibrium. But a balance so intricate is also profoundly fragile. And high above this world, unseen and utterly indifferent, the agent of that fragility is drawing closer. You pull your consciousness away from the terrestrial drama. Let the sounds of the forest fade. Let the tension of the hunt dissolve. You float upwards, rising through the thick, humid air, past the canopy of the giant conifers, and through the thin wisps of clouds. The curve of the earth becomes apparent, a vast blue and white crescent against an infinite black. You keep rising, leaving the atmosphere behind, entering the profound absolute silence of interplanetary space. The sun is a blazing, unfiltered white, and the planet below is a breathtaking swirl of ocean and cloud, utterly peaceful from this divine vantage point. There is no hint of the apocalypse to come. The agent of that apocalypse is here with you, in the cold, silent void. It is not just a rock. To call it that is to diminish its terrible significance. Before you is a mountain of primordial matter, 6 miles wide, tumbling slowly through the darkness. This is the Chicxulub Impactor. It is a carbonaceous chondrite asteroid, a relic from the very dawn of our solar system. Its substance was forged in the same nebular cloud that gave birth to our Sun and all the planets 4.6 billion years ago. For eons, it drifted as part of a larger body in the main asteroid belt, that chaotic river of rock and ice flowing between the orbits of Mars and Jupiter. But millions of years ago, a random gravitational nudge, perhaps from the immense pull of Jupiter, the system's resident bully, or a cosmic collision with another asteroid, knocked it from its stable path and sent it careening on a new trajectory, one that would intersect with the third planet from the Sun. Its journey has been unimaginably long and lonely. You can see its surface, a dark, pitted landscape of craters within craters, a testament to countless smaller impacts it has endured over billions of years. It doesn't glow or burn out here. It is a ghost, absorbing the sun's light, its surface colder than anything on Earth. It tumbles end over end in the silence, utterly indifferent to its destination. It has no malice, no intent. It is simply an object obeying the fundamental laws of physics, a cosmic bullet fired billions of years ago, whose target is only now coming into view. And its speed is staggering. It is not drifting. It is screaming through the void at more than 40,000 miles per hour, so fast it could cross the Atlantic Ocean in under 5 minutes. For a time, scientists believed they had pinpointed its exact origin story, a quirky tidbit of cosmic detective work. They theorized it was a fragment from a much larger asteroid that shattered in a collision about 160 million years ago, creating a collection of rocks known as the Baptistina family. For a while, this was the leading theory. However, more recent and detailed observations from NASA's WISE telescope have shown that the original Baptistina asteroid broke up much more recently, making it impossible for a piece of it to have been the Chicxulub impactor. And so, scholars still argue whether it was a lone wanderer from the outer edges of the asteroid belt or a piece of a different, more ancient cosmic breakup. Its precise birthplace remains a cold case. From your vantage point beside the asteroid, you see it cross the faint red path of Mars's orbit. Earth is no longer a distant marble. It has grown in the blackness, now a stunning full disk of life. You can almost make out the continents, the great swirls of weather systems, the deep blue of its oceans. Down there, the Tyrannosaurus is still hunting. The Triceratops is still grazing. The small, furry mammals are still hiding. 165 million years of an evolutionary dynasty is playing out its final ordinary moments. They have no idea that their world has an appointment that it cannot miss, an appointment with a silent, tumbling mountain that is now just hours away from home. You descend back to Earth, the cosmic perspective shrinking until you are once again standing among the giant ferns and humid air of the late Cretaceous. The sun is high and bright, casting sharp shadows on the forest floor. It is, by all accounts, a perfectly normal day. The standoff between the Tyrannosaurus and the Triceratops herd has de-escalated. The great predator, perhaps realizing the effort of attacking an organized defense wasn't worth the risk of injury, has backed away. The herd, still wary, has resumed its cautious grazing. The world has returned to its familiar rhythm, for a little while at least. High above the canopy, a different kind of life unfolds. A Quetzalcoatlus northropi, one of the largest flying creatures to have ever existed, is circling on vast thermal updrafts. Its sheer size is difficult to comprehend. With a wingspan stretching 36 feet, it is as wide as a small Cessna airplane. It soars with an impossible grace, its long, toothless beak pointed downwards as its keen eyes scan the ground for a potential meal. A small dinosaur, perhaps, or a stranded fish. For a long time, the very physics of this creature was a scientific oddity. How could something so large possibly get airborne? The quirky tidbit that paleontologists have pieced together is that it likely didn't take off like a bird. Instead, it probably used a quad launch. Crouching down on all fours, using its powerful folded wings as front limbs, it would have vaulted itself into the air with an explosive push, like a giant, leathery bat. But today, its flight is not steady. The creature seems agitated. It flaps its immense wings more than necessary, struggling to maintain its altitude in air currents that have suddenly become unpredictable. It feels a subtle, yet pervasive shift in the atmospheric pressure, a strange vibration in the air that its highly attuned senses cannot ignore. It is the first, almost imperceptible tremor of the coming earthquake in the sky. This growing wrongness trickles down to the forest floor. The T-Rex, which had begun to stalk a smaller, lone herbivore, suddenly stops. It raises its massive head, nostrils flaring, testing the air for a threat it cannot place. Its prey forgotten, it turns its gaze towards the horizon, a deep, instinctual anxiety overriding the immediate drive of hunger. The Triceratops herd also ceases its grazing. They gather in a tight, nervous bunch, their massive heads swinging back and forth. Even the insects seem to fall silent. The vibrant hum of the forest fades into an eerie, unnatural quiet. This isn't a magical premonition. You're not watching animals with a sixth sense. This is biology. It is the reaction of nervous systems honed by millions of years of evolution to survive. To notice the slightest deviation from the norm, to recognize when the patterns of the world are broken. The scientific evidence for what they might be sensing lies in the physics of the asteroid's approach. As that mountain of rock began to hit the absolute upper wisps of the Earth's atmosphere, traveling at dozens of times the speed of sound, it would have generated immensely powerful, low-frequency sound waves. This is infrasound. It's a sound so deep it's below the range of human hearing, but large animals, like elephants and whales today, can perceive it. To the dinosaurs, it would have been a deeply unsettling, directionless hum, a vibration felt in their bones and massive body cavities. It might have even been accompanied by slight disturbances in the planet's magnetic field, as the incoming object ionized the upper atmosphere. They don't know what it is. They just know that something is coming. Something vast, something fast, and something that is fundamentally alien to the natural order of their world. The day is no longer ordinary. It is now a countdown. The animal's unease suddenly finds a focus. In the bright blue canvas of the sky, a new star is born. It is a tiny, impossibly brilliant pinprick of light, far brighter than Venus on a clear night. But it's not twinkling, and it's not still. Any creature that happens to look up sees it, and the sight is deeply, fundamentally wrong. It grows slowly at first, then with terrifying speed, the pinprick swelling into a disk, a malevolent second sun burning in the daytime sky. You are witnessing the final moments of the asteroid's long journey. It has just breached the Kármán line, the official boundary of space, and is now tearing through the upper atmosphere. The physics of this moment are apocalyptic. As the 6-mile-wide mountain of rock plows through the air at over 40,000 miles per hour, the air molecules in its path have no time to move out of the way. They are compressed into a superheated layer of plasma, a sheath of incandescent gas hotter than the surface of the sun. This is the scientific evidence behind the blinding light. The asteroid has become a bolide, a firebrand of cosmic proportions. The rock itself isn't burning. It is the very atmosphere that is being ignited by its passage. This violent compression of air creates a shock wave on a planetary scale. The subtle, low-frequency infrasound the animals felt earlier is now a continuous, thundering roar that seems to come from everywhere at once. It is a sound that builds and builds, a terrifying crescendo that shakes the leaves on the trees and makes the ground tremble. It is the sound of the sky itself being ripped apart. For the dinosaurs on the ground, the spectacle is one of both horror and a strange, terrible beauty. The bolide is now a thick, incandescent streak of fire, traversing the entire sky in a matter of seconds. It is so bright that it casts sharp, moving shadows on the ground, a second set of shadows that dance and whip around as the object screams overhead. The light is painful to look at, a searing white-hot glare that leaves after-images burned into the vision of any creature that dares to glance at it. The air around you begins to feel warm, and it crackles with an unnatural static charge, the smell of ozone, like the air after a lightning strike, filling your lungs. Scholars still argue whether the plasma trail would have been a pure, brilliant white, or if it would have been tinged with the spectral colors of vaporizing minerals from the asteroid's crust and superheated atmospheric gases, a fleeting toxic rainbow heralding the end of the world. The great Quetzalcoatlus, soaring high above, is caught in the turbulence of its passage. The air around it becomes a chaotic storm of pressure waves, and the creature is tossed about like a leaf in a hurricane, its massive wings struggling to find purchase in a sky that has become an enemy. The fiery streak does not burn out, it does not fade. It simply grows larger, brighter, and lower. Its destination is now clear. It is heading for the turquoise waters of what will one day be the Gulf of Mexico. This is a crucial, mainstream historical fact that sealed the planet's fate. The impact site was not deep ocean or solid continental rock. It was a shallow tropical sea covering a thick platform of carbonate and sulfate rocks. When the asteroid struck this specific geology, it would not only vaporize water and rock, but also immense quantities of sulfur, a detail that would prove catastrophic for the entire global climate in the hours and days to come. The stage is set. The harbinger has crossed the sky. The final impact is now just seconds away. The fiery mountain in the sky touches the sea. For a fraction of a second, the universe seems to hold its breath. There is no splash. The shallow tropical water of the Yucatan platform, hundreds of feet deep, simply vanishes, flashing into superheated steam without ever having a chance to boil. Time seems to stretch and distort the way it does in dreams, a silent, impossibly bright moment of contact. But the universe has no obligation to provide cinematic slow motion. The moment breaks, and reality erupts with a violence that is beyond the comprehension of any living mind. The energy released is a number so large it becomes an abstraction. It is the equivalent of over 100 trillion tons of TNT, a mainstream historical fact that is easy to say and impossible to truly grasp. Picture millions of the most powerful nuclear weapons ever built by humankind, all detonating in the exact same spot at the exact same instant. The initial flash of light is brighter than 1,000 suns. Any creature within 1,000 miles that was unlucky enough to be looking in that direction is instantly and permanently blinded, its optic nerves seared to nothing. The light is so intense it bleaches the color from the world, turning everything into a stark, overexposed photograph of white and black. Under the force of this impossible blow, the Earth's crust ceases to be solid. It behaves like a liquid, a pond ripple in reverse. In less than a minute, a hole is blasted into the planet. A transient crater over 60 miles wide and nearly 20 miles deep is carved out of the rock. The entire 6-mile-wide asteroid and a vastly greater volume of the Earth's crust are not melted, not broken, but vaporized, turned into an incandescent gas hotter than the sun. At the heart of this new chasm, the compressed rock rebounds. An immense central peak of molten rock surges upwards at supersonic speed, a temporary mountain taller than Everest, a quirky tidbit of physics that lasts for only a minute before it, too, collapses outwards. This collapsing peak forms a circular ridge of shattered and melted rock, the peak ring that defines this type of large impact crater. And this isn't speculation. This is the story written in the rocks. The scientific evidence comes from modern deep-sea drilling expeditions that have bored miles into the buried crater. They have brought up core samples of this exact peak ring, finding the telltale signs of the impact. Granite that should be deep in the crust, thrown miles upwards, and shocked quartz, a type of crystal whose internal structure can only be formed by the kind of unimaginable pressures found at ground zero of a nuclear bomb or a major asteroid impact. And then comes the sound. It arrives a fraction of a second after the flash, and it is the loudest sound the Earth has ever produced. It is not a boom. It is a physical concussion, a roar so profound that it would have instantly ruptured the lungs and internal organs of any creature for hundreds of miles. It is a sound that does not just enter the ears, but is felt in the bones, in the teeth, a vibration so violent it would have shaken animals to pieces. For those further away, it would be a deafening, continuous thunder that would roll on for hours, the sound of a world being broken. This is the sound of rock turning to gas, of an ocean turning to steam, and of a 165-million-year-old dynasty coming to a sudden, violent, and absolute end. The cataclysm now radiates outwards from ground zero in a series of expanding, concentric rings of destruction, each one a different flavor of apocalypse. The first and fastest of these is not a wave of force, but a wave of pure energy. An intense thermal pulse, a blast of infrared radiation, erupts from the impact site, traveling at the speed of light. For hundreds of miles in every direction, the world is put into a planetary-sized oven. The air itself is superheated to hundreds of degrees in a fraction of a second. Forests don't catch fire. They simply explode into flame. Rivers and lakes flash boil, erupting in great clouds of steam. Any dinosaur unlucky enough to be caught in this zone is cooked from the inside out before its nervous system even has time to register the pain. This is a zone of instant, silent sterilization. Simultaneously, the material displaced by the impact, a mixture of the vaporized asteroid and 10,000 cubic miles of the Earth's crust, is blasted upwards. It forms a vast, expanding ring of incandescent vapor and molten rock, an ejector curtain that tears a hole in the atmosphere and punches out into the vacuum of space. From the ground, it would look as if the edges of the world were peeling upwards into a glowing red-hot crown, a terrifying sight that would be visible across the entire continent. This material, now on a suborbital trajectory, will have its own dreadful role to play a little later on a global scale. But for now, The more immediate threat is the second ring of destruction, moving slower than light, but faster than sound. This is the ground-level blast wave, the physical manifestation of the impact's power. It is not wind, it is a solid wall of compressed air, a shock wave that scours the surface of the planet clean. It radiates outwards from the crater at supersonic speeds, and its passage is absolute. Imagine the most powerful hurricane in recorded history, a Category 5 storm with winds of 200 miles per hour. Now, imagine something 5 times stronger. The quirky tidbit from the computer models is that the winds generated by this blast wave would have exceeded 600 miles per hour, 1,000 kilometers per hour. Nothing can withstand it. Let's put you in the path of this wave. Imagine you are a member of a dinosaur herd in what is now northern Mexico, perhaps 500 miles from ground zero. The first thing you experience is the blinding flash on the southern horizon, a light so bright it feels like the sun has fallen from the sky. A few seconds later, a wave of unbearable heat washes over you. The thermal pulse, diminished by distance but still hot enough to scorch your skin and set the driest foliage smoldering. You and your herd panic, running blindly away from the heat. But there is nowhere to go. And then you hear it. A low, continuous roar that grows louder and louder until it becomes a deafening wall of sound. This is the blast wave arriving. You see it on the horizon, a shimmering distortion in the air, a line of utter devastation moving across the landscape. The forest before it simply vanishes, the trees pulverized into splinters and dust. The ground itself seems to shake apart. The wave hits your herd, and the world dissolves into a chaos of unimaginable force. The 7-ton bodies of your companions are picked up and thrown like leaves in a gale. The roar is the last thing you ever know. Scientists still debate the exact sequence and overlapping radii of these destructive forces, but the scientific evidence is clear. In the thin layer of rock that marks this event, known as the KPG boundary, geologists find an immense spike in charcoal and soot. This is the carbon signature of a world on fire, the ash of the countless forests that were ignited by the thermal pulse and then flattened by the blast wave. For a radius of at least 1,000 miles, and likely more, the vibrant Cretaceous landscape was transformed into a flat, black, smoldering wasteland in less than an hour. The destruction now goes global, carried not by a shock wave, but by simple, brutal gravity. Remember that curtain of vaporized rock and asteroid that was blasted high above the atmosphere? It wasn't moving fast enough to achieve orbit or escape the planet's pull. For a few brief, silent minutes, trillions of tons of molten earth hung in the cold vacuum of space. Now that material is coming home. As it travels through the void, the molten blobs cool and solidify into tiny spherals of glass, most no bigger than a grain of sand. They are called Tektites, and they are about to become the agents of a planetary firestorm. This cloud of newly formed glass beads, once a localized plume, has now spread on suborbital trajectories across the entire globe, and it begins to rain down everywhere at once. As these trillions upon trillions of tiny projectiles re-enter the upper atmosphere, they are met with the same frictional forces that created the initial bolide, but on a macro scale. Each grain of glass is heated to incandescence, glowing a bright cherry red. The effect is that the entire sky from pole to pole, from the hemisphere of impact to the one facing the opposite direction, begins to glow. It is as if a colossal heating element has been switched on, wrapping the whole planet. This is the mainstream historical fact known as the global broiler effect. For a period of hours, the radiant heat from the glowing sky would have raised the surface temperature to that of a pizza oven. This isn't a theory built on speculation. This is the story told by a thin, dark line in the rock record all over the world. This is the KPG boundary, the scar that separates the age of dinosaurs from the age of mammals. When geologists examine this layer under a microscope, they find it is packed with these perfect, glassy micro-tektites, the scientific evidence of a fiery rain that fell everywhere on Earth on the very same day. The consequences of this global heat lamp were inevitable and catastrophic. The planet's vast forests, already stressed by the shaking ground and strange atmospheric phenomena, were suddenly baked from above. The moisture was stripped from their leaves, and the ground temperature soared. And then they ignited. Not just near the impact, but everywhere. The great conifer forests of Asia, the fern prairies of Africa, the lush jungles of South America, they all erupted into a single planetary inferno. It was the beginning of a firestorm on a scale that is almost impossible to imagine. A blaze that would consume a significant portion of the world's biomass. Scholars still argue whether the initial radiant pulse was hot enough to ignite healthy, wet forests on its own, or if it primarily ignited the dead leaf litter on the forest floor, which then spread into an uncontrollable crown fire. In the end, the distinction is academic. The world was set ablaze. Now, imagine you are a dinosaur on the other side of the planet, in what will one day be China. You did not see the flash. The blast wave will never reach you. Your day was strange. The ground has been shaking with a violent, unending earthquake for the last hour. But the real horror is just beginning. You look up at the sky, and it is no longer blue. It is beginning to glow a dull, menacing, and ever-brightening red. It's not the sun. The glow is coming from everywhere, as if the very air is on fire. The temperature starts to rise, rapidly and unnervingly. The air, once humid, becomes scorchingly dry and hard to breathe. Then something new begins to fall. It's not rain. It's a shower of tiny, glowing embers, like a rain of sparks from a great cosmic forge. These are the Tektites. Where they land, they hiss and set the dry ferns smoldering. Panic erupts. Your herd begins to run, but there is nowhere to run to. The heat is not coming from the horizon. It is coming from above. The entire world has become a trap. And all around you, the forest is beginning to smoke. While the sky is turning into a global furnace, the very ground beneath your feet becomes a traitor. The solid earth, the one constant in any creature's life, is convulsing in a planetary seizure. The impact didn't just create a crater, it sent a seismic shockwave of almost unimaginable power ripping through the planet's crust. Modern earthquakes are measured on the Richter scale, which is logarithmic. A magnitude 9, one of the most powerful ever recorded by humans, is terrifying. The Chicxulub impact generated the equivalent of a magnitude 11, or possibly even 12, earthquake. This is not just a couple of steps up the ladder. The energy released is hundreds, if not thousands of times greater. This is a mainstream historical fact of the event. The planet rang like a bell, a vibration so profound it would have continued to echo through the deep mantle for weeks. This primary shockwave travels outwards through the rock at several miles per second, a ripple of pure force, that makes the surface of the planet behave like the surface of a stormy sea. You are standing thousands of miles from the impact, yet the ground begins to heave and roll in long, sickening waves. Trees whip back and forth as if in a hurricane, but there is no wind. Cracks split the earth, and the roar of shifting rock becomes a constant, terrifying bass note to the horror unfolding in the sky. This planetary tremor does more than just shake the ground. It triggers sympathetic earthquakes along every major fault line on the globe. It is a cascade of geological chaos. Entire mountain ranges are shaken, causing landslides on a continental scale, burying valleys and damming rivers in an instant. Volcanoes that were dormant are shocked back to life, while those that were already active are kicked into a new, far more violent phase of eruption, adding their own plumes of ash and gas to the already choked atmosphere. A particularly fascinating and heated scholarly debate centers on the Deccan Traps in what is now India. At the time of the impact, this was one of the largest volcanic provinces in Earth's history, already flooding the subcontinent with lava. Scientists still argue whether the impact's seismic waves, traveling directly through the planet's core, could have focused on the exact opposite side of the Earth, the Antipode, and dramatically amplified the Deccan eruptions, a sort of cosmic 1-2 punch against life. Perhaps the most astonishing piece of scientific evidence for this immediate global shaking comes from a fossil site in North Dakota called Tanis. This site has been called a snapshot of the last day of the dinosaurs, and for good reason. At the time, it was a peaceful river system, nearly 2,000 miles north of the impact. The inhabitants of this river would have had no idea what was happening in the Gulf of Mexico, but within about 15 to 30 minutes of the impact, the seismic waves arrived. They didn't just shake the ground, they caused the entire river to slosh back and forth violently in a massive standing wave called a seiche. A 10-meter wall of water surged up the river against the current, carrying everything with it: fish, animals, logs, and burying it all in a thick layer of mud. When paleontologists excavated this site, they found a tangled mass grave of freshwater sturgeon, paddlefish, and even the occasional dinosaur. The most incredible part? They found fish with Tektites, those tiny glass beads from the fiery rain. Remember them? Lodged in their gills. This means the fish were alive, breathing in the falling debris from the impact at the exact moment the earthquake wave arrived and buried them. Tanis is a perfect, almost unbelievable fossilized record of the first hour of the apocalypse, thousands of miles from ground zero. For any surviving dinosaur, the world has lost all meaning. The sky is glowing with a malevolent heat. The air is filled with falling embers. And now, the very ground they stand on has become a rolling, unpredictable sea of rock. There is no solid place left in the world. There is no shelter from a planet that is actively trying to shake itself apart. While the land is being shaken and burned, the ocean responds. The fury all its own. The impact, remember, didn't strike a dry continent. It slammed into a shallow tropical sea. The initial blast vaporized a hole in the ocean over 100 miles wide, exposing the seabed to the raw vacuum of the ejector plume for a few horrifying seconds. But water, unlike rock, is fluid and abhors a vacuum. The surrounding ocean, heaped up by the initial blast, now comes crashing back in towards the center of the crater. It is an unimaginable volume of water, a liquid wall collapsing on itself. As this torrent of seawater surges into the still-forming crater, it collides with the rapidly rising central peak of molten rock. The result is not a splash. It is a collision of titanic forces that throws the water back up and outwards in a colossal circular wave. This is the birth of the Mega-Tsunami. Computer models, trying to calculate the scale of this event, produce numbers that border on the unbelievable. The initial wave, radiating out from the crater's edge, may have been over a mile high. As it moved into the deeper waters of the Gulf of Mexico, it would have settled, but still remained a wall of water hundreds of meters tall, 3 or 4 times the height of the Statue of Liberty, and it was moving at the speed of a jet airliner. This is not wild speculation. This is a mainstream historical fact, written in the geological record across the entire Gulf Coast. The scientific evidence is found in a bizarre, chaotic layer of rock that geologists can trace from Texas to Florida and beyond. This layer is a jumbled, unsorted mashup of everything the wave picked up. Sand from the beaches, boulders from the seafloor, shattered trees from the coastal forests, and the fossils of both marine and land animals all mixed together. There are places in modern-day Texas, hundreds of miles from the nearest coastline of the time, that have these thick tsunami deposits. It's the geological equivalent of finding the contents of your entire house, plus your neighbor's house and half the street, smashed into a single layer of concrete in your attic. Now, place yourself on a coastal plain of that era. You are a dinosaur that has, by some miracle, survived the thermal pulse and the initial earthquake. The world is a nightmare of a glowing sky and shaking ground, but you are alive. The horror, however, is far from over. You notice that the sea, which was on the horizon, has vanished. The water has pulled back, exposing the seabed for miles in an eerie, unnatural calm. And then you see it. It does not look like a wave. It looks like the horizon itself is rising. A dark blue line in the distance grows and grows until it fills your entire field of vision. A moving cliff of water that scrapes the smoke-filled sky. There is no outrunning it. There is no high ground that is high enough. The sound arrives first, a deep, continuous roar that drowns out even the thunder of the ongoing earthquakes. When the wave hits the coastline, the destruction is absolute and instantaneous. It doesn't break. It scours. A wall of water moving at over 500 miles per hour and carrying a slurry of rock, sand, and debris obliterates everything. The lush coastal forests of ferns and cycads are stripped from the land, the very soil eroded down to bare rock in seconds. Herds of dinosaurs are swept up and pulverized. The wave doesn't stop at the beach. It travels for hundreds of miles inland, a rushing, turbulent flood that fills entire river valleys and turns low-lying plains into a temporary, violent extension of the sea. Scholars still argue about the maximum inland reach, or run-up, of the wave, but all models agree it was an inundation on a continental scale. And this was just the first and biggest wave. The ocean, now a chaotic, churning mess, would have sloshed back and forth across the Gulf for days, sending a series of subsequent, smaller tsunamis to batter the already devastated coastlines. And the chaos didn't stay contained. This immense surge of energy propagated out into the global ocean. Hours after the impact, a massive, unexpected tsunami, diminished by its journey but still dozens of feet high, would have slammed into the coasts of what are now Europe and Africa. 12 hours later, it would have reached the far shores of the Proto-Pacific. No coastline on Earth was left untouched. The sea, the source of all life, had been weaponized by the impact, becoming another agent of global extinction. The immediate violent phase of the apocalypse, the shaking, the burning, the flooding, is now transitioning into something slower, more insidious, but no less deadly. The global firestorms, which have been raging for hours, have become a very engine of soot. Trillions of tons of incinerated Cretaceous forest, the carbonized remains of giant ferns, conifers, and the first flowering plants are being pumped into the sky in vast black plumes. This isn't just smoke that will dissipate in the wind. The convective heat from the fires is so intense that it injects this fine black soot high into the stratosphere, the stable upper layer of the atmosphere. At the same time, the initial plume from the impact itself, that colossal mushroom cloud of vaporized rock and asteroid, is also spreading through the stratosphere. It is a toxic cocktail of pulverized rock dust, but more importantly, it contains vast quantities of sulfur aerosols, the chemical byproduct of that vaporized, sulfur-rich seabed. This is a quirky and deadly tidbit of atmospheric science. Fine particles like soot and sulfate aerosols, once lofted into the stratosphere, can remain suspended for years, sometimes even decades. They are above the weather, above the clouds and the rain that would normally wash them out of the sky. They are there to stay. This lethal combination of impact debris and global soot begins to coalesce into a thick, impenetrable blanket, a shroud that is wrapping itself around the entire planet. The scientific evidence for this is stark and unequivocal. At every KPG boundary site across the globe, right on top of the layer of iridium-rich dust and glassy tektites, geologists find a distinct, dark band of carbon. It is the soot layer, the fingerprint of a burned world, and the undeniable proof of the darkness that followed. For any creature that has managed to survive the horrors of the last few hours, a new and deeply profound terror is unfolding. The sky, which had been glowing an infernal oven-hot red from the rain of tektites, begins to change. The red glow fades, not into the familiar blue of day, but into a deepening, oppressive gray. The sun, which was a dim, hazy disk behind the smoke, begins to vanish entirely. Scholars still argue whether the transition to total darkness took a few hours or a full day to become globally absolute. But for the survivors on the ground, the effect was the same. The light of their world was being extinguished. Imagine you are one of those survivors. You are a small dromaeosaur, a swift, intelligent predator, huddled in the relative safety of a rock crevice, having narrowly escaped the fire that swept through your territory. Your body is trembling from the ceaseless earthquakes. The air smells of ash and death. But now, the creeping darkness brings a new psychological horror. The familiar cycle of day and night, the most fundamental rhythm of life on Earth, has been broken. Day is turning into a night from which there will be no dawn. The shadows lengthen and merge, not with the soft familiarity of twilight, but with a finality that feels absolute. The last sliver of sunlight disappears. You are now plunged into a darkness more complete than any moonless midnight. A blackness so profound that you cannot see your own clawed hand in front of your face. The world has been shaken. The world has been burned. The world has been flooded. And now the sun has been stolen from the sky. The sensory inputs that have defined your entire existence, the warmth of the sun, the sight of your prey, the familiar shape of your territory, are all gone. You are left alone in a cold, suffocating blackness, haunted by the thunder of distant earthquakes and the howling of a wind that carries only the stench of a dead planet. The familiar world is gone. You are now a resident of a cold, dark nightmare, and the true, long extinction has just begun. With the sun gone, the Earth's engine has been shut off. The primary source of all energy for life on the surface has been disconnected, as surely as if someone had pulled a celestial plug. The process that underpins nearly every food chain on the planet, photosynthesis, stops instantly and globally. This is the mainstream historical fact that becomes the true engine of the mass extinction. Without sunlight, plants can no longer convert carbon dioxide into sugar. They can no longer grow. They can no longer breathe. The great green lung of the world has collapsed. The second immediate consequence is a catastrophic drop in temperature. The thick blanket of stratospheric soot and dust that blocks the incoming sunlight is also quite good at trapping some of the planet's residual heat, but it's not enough to stop the inevitable. The hothouse world of the Cretaceous, with its balmy tropical climate extending far towards the poles, is plunged into a sudden, vicious winter. It's a climate shock of unimaginable severity. Over the next days and weeks, average temperatures over land plummet by as much as 25 degrees Celsius or 45 degrees Fahrenheit. Tropical paradises experience deep, killing freezes for the first time in millions of years. The world starts to ice over. For the dinosaurs, this is a profound biological crisis. Scholars still argue whether they were truly cold-blooded like modern reptiles, fully warm-blooded like birds and mammals, or something in between. A state called mesothermy. Most evidence points to this middle ground, that they were active and energetic, but their metabolism wasn't the internal furnace of a mammal. This made them uniquely vulnerable to this specific catastrophe. They weren't adapted to hide and hibernate through a long winter like some reptiles, nor could they generate enough of their own body heat to endure a prolonged, foodless freeze like a mammal could. The largest of them were the first to suffer. The quirky tidbit of their biology is that their immense size, a phenomenon called gigantothermy, helped them retain heat in a stable climate. But in this new reality, their huge bodies became a liability, a massive furnace that required impossible amounts of fuel to keep running in the biting cold, fuel that no longer existed. We know this happened because of the elegant scientific evidence preserved in the fossil record. Scientists can analyze the chemical signatures in the shells of tiny marine organisms and even in the teeth of land animals from just before and just after the impact. Specifically, they measure the ratios of different oxygen isotopes, which act as a reliable prehistoric thermometer. The data shows a sharp, sudden, and dramatic drop in global temperatures, a clear signature of the impact winter that began the moment the sun vanished. You are now in the body of a survivor, perhaps a mid-sized hadrosaur, wandering through the freezing darkness. The world is utterly alien. The air, once thick and humid, is now thin, crisp, and painfully cold. A hard frost, something your species has never experienced before, glitters on the ash-covered leaves of the dying ferns. Every breath is a struggle. Your primary instinct screams at you to find shelter. You stumble through the gloom, the ground still occasionally trembling with aftershocks, searching for a deep ravine, a cave. Anything to break the grip of a wind that feels like it's siphoning the very life from your bones. You might find a shallow overhang and huddle there with the last few members of your herd, sharing what little body heat you have left. But it's a false hope. The shelter may offer a brief respite from the killing cold, but it offers no escape from the two greater killers that now rule this new world: the absolute, unending darkness and the gnawing, inescapable promise of starvation. Just when it seems the world cannot possibly become more hostile, a new torment begins to fall from the perpetually black sky. It is not snow, despite the bitter cold. It is rain. But it is not the life-giving rain your world has always known. It is a slick, greasy precipitation that stings the skin and carries a sharp, chemical odor, like the smell of a volcano's breath. This is the acid rain, and it is the direct chemical consequence of the impact's specific location. The mainstream historical fact that turned the impact from a catastrophe into a true global killer was the geology of the Yucatan Peninsula. The asteroid didn't just hit granite. It slammed into a thick platform of sedimentary rock, rich in a mineral called anhydrite. This is essentially a rock made of sulfur. The immense heat of the impact vaporized this rock, blasting trillions of tons of sulfur dioxide and trioxide directly into the stratosphere. Up there, in the cold, dark upper atmosphere, these sulfur compounds combined with the water vapor from the vaporized ocean to form vast planet-enveloping clouds of sulfuric acid. And now, that acid is beginning to fall. The deluge is relentless. In the hardest-hit areas, scholars still argue whether the rain would have been as acidic as vinegar, or, in the initial hours, as corrosive as battery acid. For any surviving animal, it is a form of chemical warfare. The rain falls on your hide, and it burns, creating sores and lesions. It sears your eyes, making the absolute darkness even more agonizing. You try to drink from a puddle, but the water is sour and burns your throat. Any surviving plant life, the last hope for the world's starving herbivores, is decimated. The acid defoliates the leaves, burns the roots, and leaves behind a landscape not just dead and frozen, but chemically sterilized. The most profound and deadly effects, however, are happening in the world's oceans. The acid rain falls onto the surface of the sea, drastically lowering the pH of the upper layers. For an entire class of microscopic organisms that form the absolute base of the marine food chain, this is a death sentence. These are the planktonic foraminifera and coccolithophores, tiny creatures that build beautiful, intricate shells out of calcium carbonate. In the newly acidified seawater, their shells can no longer form. In fact, the shells of the living and the dead simply begin to dissolve. This massive die-off of the ocean's primary producers represents the single greatest collapse of a food web in the planet's history. And here lies a fascinating and quirky tidbit, a piece of scientific evidence you can see with your own eyes if you know where to look. For millions of years, as these tiny shelled creatures died, they formed a constant rain of calcium carbonate onto the seafloor, creating the thick layers of chalk and limestone that characterize the Cretaceous period. Think of the white cliffs of Dover. But if you look at the rock layer directly on top of the KPG boundary, the chalk vanishes. It is replaced by a thin layer of simple dark clay. Geologists call this the plankton dead zone, or the boundary clay. It is the fossilized tombstone of the ocean's foundation, a silent, stark testament to the moment the acid rain fell and the microscopic heart of the seas stopped beating. The great marine reptiles, the mosasaurs and plesiosaurs, are already doomed by this. They just don't know it yet. They are swimming in a dying ocean, their food supply dissolving away beneath them. The cold, the darkness, and the acid rain have now set the stage for the great, silent dying. The true engine of extinction is not the spectacular violence of the impact, but the slow, grinding, and inexorable process of starvation. The foundation of nearly every complex ecosystem on the planet, the plant life, is crumbling. With no sunlight, photosynthesis, the miracle that turns light and air into life, has ceased. The world's plants are now, in essence, holding their breath, and with the constant drizzle of sulfuric acid burning their leaves and poisoning the soil, their breath is running out. On a massive planetary scale, the vibrant green of the Cretaceous is turning to a rotting skeletal brown. The great forests of conifers, the endless prairies of ferns, and the lush groves of magnolia-like flowering plants are dying. This isn't a seasonal change, it is a terminal, systemic collapse. The energy that once flowed from the sun into the leaves and then into the creatures that ate the leaves has been cut off at its source. The food chain has been severed at its absolute base. The most powerful scientific evidence for this botanical apocalypse is also, paradoxically, the evidence for the very first signs of life's recovery. In the rock layers just above the soot and iridium of the KPG boundary, paleontologists find something extraordinary: a massive, overwhelming spike in the number of fern spores. It's called the fern spike. For a world that had been full of diverse pollen from countless species of plants, this sudden, monotonous layer of nothing but fern spores tells a clear two-part story. The first part is that every other plant was gone. The great forests were dead, creating an open, devastated landscape. The second part is that the first organisms to recolonize this sterilized world were the hardiest of opportunists: ferns. For thousands of years after the impact, Earth was a monotonous gray world covered in a carpet of ferns. This fern spike is the ghost of the lost Cretaceous forests. But for the survivors in the immediate aftermath, there is no hope of a fern-covered future. There is only the agonizing present. For the great herbivores, the Triceratops, the duck-billed hadrosaurs, the armored ankylosaurs, this is the end of the line. Their entire existence, their immense size, their specialized teeth and complex digestive systems were all exquisitely adapted to one thing: processing vast quantities of fresh vegetation. And that vegetation is now gone. You are one of them. A Triceratops, huddled with the last of your herd in a frozen, dark valley. The gnawing emptiness in your colossal gut has become a constant, dull ache. For days you have wandered through the gloom, your powerful beak prodding at the familiar shapes of plants that are now nothing but limp, blackened slime. The acid has ruined them, and the cold has frozen them. There is no nourishment here. Driven by a desperation your species has never known, you begin to try things you would never have touched before. You use your horns to strip the bark from a dead conifer, chewing the tough, woody fibers. Your specialized shearing teeth, designed for slicing cycad fronds, struggle to grind the bark. And your gut, a finely tuned fermentation vat for leafy greens, has no idea how to process this poor, abrasive substitute. It only makes the hunger worse. You see others in your herd eating the rotting leaf litter, a slurry of ash and decaying plant matter, hoping to find some vestige of sustenance. Scholars still argue whether some of these giant herbivores, in their final desperate throes of starvation, might have turned to scavenging the frozen carcasses of other animals, a complete and shocking break from their biological programming. For now, it remains a grim, unanswered question. The days blur into one long, cold, dark night. Your massive body, once a fortress of power, now feels like an anchor, a metabolic burden that demands fuel you cannot provide. The herd thins. One by one, your companions lie down in the freezing mud, too weak to rise again. Eventually, your own immense strength gives out. You stumble to your knees, the great horned head suddenly too heavy to hold up. You lay down in the darkness, the tremors of the dying earth, a faint, final vibration, and wait for the end. This silent, lonely death is being repeated millions of times over, all across the globe. The great grazers and browsers are vanishing from the earth, and with them goes the life-giving sound of the forests. The rustle of a giant body moving through the ferns, the snap of a branch in a powerful beak, the low bellow of a hadrosaur calling to its herd. All of it is fading. The once vibrant forests are now just silent, rotting graveyards under a perpetually dark sky, littered with the still immense forms of the last of the great plant-eaters. For you, the apex predator, the king of this world, the first days of the long night are not a time of famine, but of a sudden, grim and fleeting feast. As a carnivore, your fate is not tied directly to the sun, but to the flesh of the herbivores who are. While they were starving, you were discovering a world littered with opportunity. The initial cataclysm, the blast wave, the firestorms, the earthquakes, killed indiscriminately, leaving a landscape strewn with the frozen carcasses of the less fortunate. For a Tyrannosaurus rex, whose sense of smell was one of the most powerful in Earth's history, the cold, dark world was a map of death, each scent a promise of a meal. You are a shadow of your former glory, a monarch wandering through the ruins of your kingdom. You move through the silent skeletal forest, your massive feet crunching on the ash-covered frost. The acute ache of hunger, a feeling that has driven your entire existence, is a dull throb for now. Up ahead, your keen, forward-facing eyes spot a familiar shape in the gloom. The immense, horned skull and bulky form of a dead Triceratops, one of the very herd you stalked in what feels like another lifetime. It lies half-frozen in a shallow gully, its great frill shattered. This is not a hunt. There is no challenge, no glorious battle. This is merely a claim. You approach the body and get to work. Your role has changed. You are no longer a hunter, you are a scavenger. Paleontologists still debate vigorously, and have for decades, about your primary lifestyle. Were you a noble predator that hunted its own food, or a colossal opportunist? A reptilian vulture that used its size and power to bully other killers off their meals? Your incredibly large olfactory bulbs, the part of the brain that processes smell, certainly point to a life spent tracking the scent of carrion over vast distances. Now, in this dead world, the debate is moot. Every predator is a scavenger. You place one massive three-toed foot on the Triceratops's flank to brace the carcass and get to work. You use your powerful neck muscles. A quirky tidbit of your anatomy is that they were strong enough to throw a 500-pound chunk of meat 15 feet into the air to rip and tear at the tough, frozen hide. Your teeth, those infamous railroad spikes of serrated bone, are not just for piercing flesh. They are designed for crushing bone. This is a key adaptation for a scavenger, allowing you to access the rich marrow that other carnivores can't. The scientific evidence for this is found in your fossilized dung, or coprolites, which are often packed with the pulverized bone fragments of your prey. You eat everything, wasting nothing. For a week, maybe 2, this new reality seems sustainable. The world is a larder of the dead, but the feast cannot last. The cold that preserves the meat also makes it harder to consume, and your immense body burns through calories at a ferocious rate just to stay warm. And you are not alone. Other smaller carnivores, like packs of dromaeosaurs, dart in from the shadows, stealing what scraps they can when you are not looking. The supply is finite. Every carcass you find is one less that will ever exist again. The great herds of herbivores, the living engine that produced this meat, are gone. They are not hiding. They are extinct. The day comes when you finish the last of the Triceratops. You lift your great head, the scent of rot on your breath, and test the wind. You search for the next scent, the next promise of food. And for the first time, there is nothing. The air is clean, cold, and empty. The world-spanning buffet is closed. Now, the true hunger begins. The dull throb becomes a sharp, agonizing ache in your belly. The top of the food chain, once the most secure position in the world, has become the most precarious. You are completely severed from your foundation. You are a king with no subjects, a hunter with no prey. You begin to wander, a 7-ton ghost driven by the most basic and powerful of all urges. You embark on one final, desperate hunt. Your senses are on fire, every nerve straining to detect a sound, a movement, a scent of life in the silent blackness. But there is only the whistle of the wind through the dead trees and the faint, endless rumble of the planet's dying tremors. Your greatest assets, your size, your strength, your power, are now your greatest liabilities. You are an immense engine with an empty fuel tank. Days turn into a week. The ache of hunger transforms into a spreading systemic weakness. Your powerful leg muscles begin to tremble with exhaustion. Finally, you can go no further. You find a sheltered spot beneath a rock outcropping, out of the worst of the biting wind, and you lie down. Your great head rests on the frozen, ash-covered ground. Your breathing becomes shallow. The tyrant lizard king, the ultimate predator this world has ever produced, does not die in a cataclysmic battle. You die alone, in the freezing dark of simple, ignoble starvation. The apocalypse on land is mirrored by an even more profound, though quieter, catastrophe in the vast, dark realm of the oceans. The world beneath the waves, a biosphere that dwarfs its terrestrial counterpart, is dying from the top down and the bottom up. The initial violence of the Mega-Tsunami and the scalding rain of Tektites was just the beginning. Now, the more insidious chemical and biological poisons are taking hold. The endless, stinging drizzle of sulfuric acid has turned the surface of the sea into a corrosive, toxic soup. And the darkness, the same eternal night that has frozen the continents, has starved the seas. The true heart of the ocean is not the great leviathans, but the microscopic pastures of plankton. These tiny, single-celled organisms, through the magic of photosynthesis, are the foundation of everything. They are the grass, the trees, and the flowers of the sea. But now, with no sunlight penetrating the toxic clouds, and with the very water dissolving their fragile calcium carbonate shells, they have perished on a global scale. This is the mainstream historical fact of the marine extinction. The base of the entire food chain has been wiped out in a geological instant. Imagine you are one of the ocean's great rulers, a 40-foot mosasaur, a sleek and powerful marine reptile. For days you have patrolled your territory in the growing gloom, a deep instinct telling you that the world is wrong. The water tastes strange, acrid, and it is empty. The great shoals of fish that once glittered in the depths are gone. The smaller marine reptiles you preyed upon have vanished. The ocean, once a symphony of life, is now a silent, empty cathedral. Driven by a hunger as deep and powerful as your terrestrial counterpart, the T-Rex, you dive, your powerful tail propelling you into the abyss, searching for anything. But there is nothing to find. The krill and small fish that fed on the plankton are dead. The larger fish that fed on them are dead. And now, you, at the very pinnacle of this liquid world, are starving to death in a watery desert. This wave of death consumed entire dynasties of marine life. Consider the ammonites. Getty images. These shelled, squid-like cephalopods were one of the great success stories of the Mesozoic. Their beautiful coiled shells are among the most common and recognizable fossils of the era, found in oceans all over the world. They were as plentiful as fish, a cornerstone of the marine ecosystem. And in this event, they were utterly and completely annihilated. Not a single species of ammonite survived. Herein lies one of the great, frustrating mysteries of the extinction. Scholars still argue why the ammonites perished so completely, while their very close cousins, the deep-dwelling nautiluses, managed to cling to life and survive to the present day. Was it because their eggs were planktonic, floating in the acidic surface waters, while nautilus eggs were laid in the deeper, more protected ocean? No one knows for sure. It remains a ghostly puzzle. The surface of the ocean has become a stinking, anoxic film of death. The decaying bodies of the plankton bloom, mixed with the soot from the sky and the acid from the clouds, have created a lethal barrier. Below this, a constant, grim rain of death drifts down into the depths. The bodies of fish, reptiles, ammonites, and everything else that has succumbed. As this organic matter decays, it consumes what little oxygen is left in the water, creating vast dead zones. And what of the very deepest parts of the ocean? The bizarre ecosystems huddled around volcanic hydrothermal vents, which survive on chemical energy from the Earth's core, not sunlight. Surely they were safe. Not entirely. While the vent creatures themselves may have survived the initial shock, many deep-sea ecosystems also relied on a steady fall of marine snow, the organic debris from the vibrant world above. With the surface world dead, that life-giving snow ceased to fall. It was like a city whose supply lines had been cut. Life clung on, yes, in the deepest, most isolated trenches, and around the most robust chemical oases. These were the lonely embers in a drowned and dying world, the faint, flickering hope from which the oceans would, over the course of the next 1,000,000 years, eventually be reborn. Amidst the global graveyard, in the freezing darkness and the acid-laced winds, a different story is unfolding. It's a quiet, desperate, and ultimately triumphant story of survival against all odds. While the Titans were falling, the Meek were hunkering down. The profile of a survivor in this new, brutal world is the polar opposite of a dinosaurian king. A survivor is not large, it is small. It is not a specialist, it is a generalist. And it does not rule the landscape, it hides from it, often by living inside it. Let's start with your own distant family. Imagine a creature no bigger than a rat, a furry, shrew-like mammal with a long snout, whiskers twitching in the dark, and beady black eyes that are already well adapted to a life lived in the shadows. This is your ancestor. When the sky caught fire and the ground shook, this creature was not standing in the open. It was safe in its burrow, a deep and complex tunnel insulated from the horrors above. The thermal pulse that incinerated the forests was a distant, muffled vibration. The freezing temperatures of the impact winter were blunted by the warmth of the earth. The burrow was its shield, its bunker against the apocalypse. This mammal had another crucial advantage. It was warm-blooded. Scholars still argue about the precise metabolic rates of these early mammals, but their ability to generate their own internal heat was a superpower in the new, frozen world. While the great dinosaurs, with their intermediate metabolisms, were slowly succumbing to the cold, your ancestor could shiver, burn its fat reserves, and maintain its core body temperature. Its small size, a liability in a world of giants, was now an asset. It needed far less fuel to keep its furnace burning. And it was a master of finding that fuel. It was not a picky eater. Its diet was a smorgasbord of the apocalypse. It foraged in the rotting leaf litter and ash for the things the giants ignored. Insects, worms, grubs, and the dormant, nutrient-packed roots of dead plants. This varied, non-specialized diet was the key to its success. While the Triceratops starved for lack of fresh cycads, your ancestor thrived on the resilient, hidden biosphere of the soil. Life also found a sanctuary in the water, but not in the dying oceans. Freshwater ecosystems like rivers, lakes, and swamps fared surprisingly better. This is a mainstream historical fact of the extinction event. These bodies of water were large enough to buffer the worst of the acid rain, and their food webs were structured differently. They were largely based on detritus, rotting organic material. In the aftermath of the impact, the world's rivers and lakes were choked with a sudden, massive influx of this material. The leaves, logs, and bodies of the entire dead terrestrial world. For creatures that ate detritus, it was a time of unprecedented plenty. This is why creatures like turtles, with their slow metabolisms and armored shells, and crocodiles, the ultimate aquatic ambush predators, made it through. They could wait, hunkered down in the muddy, food-rich water, for the worst to pass. Among them was a particularly quirky survivor, the Champsosaurs. These were crocodile-like aquatic reptiles, common in the rivers of the late Cretaceous. They survived the impact just fine, thriving in the post-apocalyptic waterways, only to go extinct for entirely different reasons, millions of years later, during a period of global cooling. Their story is a perfect reminder that surviving the apocalypse doesn't guarantee you a ticket to the future. But what of the dinosaurs? Did they all truly vanish? Number. Look to the skeletal branches of a dead tree. A small, shivering creature is perched there, its feathers puffed up against the cold. This is a bird. And a bird is a dinosaur. The only lineage of dinosaurs to survive the Great Dying were the aves, but not the big, strange, toothed birds of the Cretaceous. The survivors were small, and they possessed the single most important adaptation for enduring this specific cataclysm: a modern, toothless beak. The beak was the perfect tool for eating seeds. While the leaves were gone, the world's soil was a vast seed bank. Seeds are nature's perfect survival pods, durable, nutritious, and capable of lying dormant for years, waiting for the return of the sun. The dinosaurs who ate leaves starved. The dinosaurs who ate other dinosaurs starved. But the dinosaurs who could eat seeds, they had a hidden pantry, a buried treasure of stored sunlight that would allow them to outlast the long, dark night. An entire year has now passed since the sky fell. 12 times the scarred and battered Earth has completed its lonely orbit through the darkness. For you, the small, burrowing mammal, it is the only world you have ever known. The concept of a warm, bright sun is a ghost in your genes, an instinctual memory you cannot consciously access. Your reality is an eternal, freezing twilight. Scientists still debate the exact duration of the total darkness. Some models suggest it could have been absolute for 2 years, with dangerously low light levels persisting for a decade or more. A year in, the world is still a prisoner of the long night. The thickest of the stratospheric soot has begun to settle, but the sky is not blue. It is a permanent, oppressive ceiling of grey, a dirty, uniform dome that smothers all hope of a true dawn. The landscape is a bizarre and alien vista of decay. The skeletal remains of the great Cretaceous forests are still standing, but they are no longer just dead wood. They are draped, coated, and consumed by a new, triumphant kingdom of life. The fungi. With trillions of tons of dead organic matter to feast upon, the world's fungi have exploded. Vast, ghostly webs of mycelium run through the ash-covered soil, and strange, pale mushrooms sprout in silent profusion from the rotting logs. This is a quirky tidbit of the post-impact world. For a time, Earth was not a green world or a brown world, but a world of mold and mushrooms. The scientific evidence for this is found in that same boundary layer, where paleontologists find a massive spike in fungal spores, a clear sign of a planet-wide banquet of rot. This is the world you must navigate. You emerge from the relative warmth and safety of your burrow, your whiskers twitching, your nose testing the cold, damp air. The smell is one of perpetual decay, of wet earth, of mold, and of the distant, faint chemical tang that still lingers from the poisoned sky. Your life is a simple, brutal loop. Find food, avoid being food, and conserve heat. You scurry through the gloom, a tiny, warm-blooded engine of survival. You are hunting. You dart across the forest floor, your senses on high alert, listening for the faintest rustle in the leaf litter. Your prey is the other survivors of the soil. Beetles, worms, hardy insects that have also found a way to endure. You pounce, a flurry of fur and tiny, sharp teeth. Every grub, every larva, is a precious jewel of protein and fat, the fuel that will keep you alive for another cycle of darkness. But the silence is the most profound and haunting feature of this new world. The planet has lost its voice. You stop for a moment, listening. A year ago, this spot was alive with sound. The deep, rumbling bellows of hadrosaurs, the heavy footfalls of a passing ceratopsian, the piercing shriek of a hunting raptor, the leathery flap of pterosaur wings overhead. It was a constant, rich symphony of life. Now there is only the whisper of the wind whistling through the skeletal trees and the faint skittering of other, smaller survivors like yourself. The great silence is the true sound of extinction. It is a planetary quiet that is more terrifying than any roar. And then, one cycle, something is different. You emerge from your burrow, and you notice a change in the quality of the darkness. The oppressive, absolute blackness has softened. You look up at the grey, featureless ceiling of the sky, and you can just make out a faint, diffuse patch of slightly less grey. It is a dim, ghostly disk, a cataract eye in the heavens, providing no warmth, no comfort, just a weak, ethereal luminescence. It is the sun. After a long and terrible year, the first faint photons are beginning to pierce the stratospheric shroud. It is not a dawn. It is not a sunrise. But for a world that has been utterly consumed by darkness, it is the first fragile and desperately needed glimmer of hope. Decades have passed, a human lifetime. For the planet, it is less than the blink of an eye. The long, absolute night is a fading memory, but the world is still trapped in a perpetual gloom. The sun is a pale, watery disk in a sky that is permanently overcast with a thin haze of stratospheric dust. But it is enough. The weak sunlight that now reaches the surface is a catalyst, a resurrection. Life is returning. The first thing you notice is the color. The world is no longer a monochrome of black and gray. It is green. Not the rich, varied green of the lost Cretaceous, with its infinite shades of fern, cycad, and conifer. This is a single, monotonous, almost artificial green. You are standing in the heart of the fern frontier, as the scientific evidence from the fossil record so clearly shows with its fern spike. These hardy, opportunistic plants were the first to truly reclaim the wounded earth. Their spores, dormant in the poisoned soil, responded to the first touch of light and warmth, sprouting in a furious, planet-wide wave of colonization. They thrived in the disturbed, nutrient-rich soil, a mix of ash and the decaying remains of the old world, and they choked out almost everything else. The landscape is a strange and alien sight. Imagine a world covered, from horizon to horizon, in a thick, uniform carpet of ferns. They cover the plains. They blanket the hills. They choke the valleys where the skeletal forests of the past are finally rotting into the soil. It's a world that is vibrantly alive, yet strangely empty and repetitive. Scientists still argue whether this was a true planet-wide monoculture of ferns, or if there were hidden pockets of other hardy disaster taxa, scrappy, fast-growing, flowering plants that also managed to survive and find a foothold. But from your perspective on the ground, the overwhelming impression is one of endless rolling fields of green. And in this new green world, your descendants are venturing out. The small, shrew-like mammal that hid in its burrow is now the ancestor of a new generation of explorers. You see them, small, rodent-like creatures, perhaps early multituberculates, creeping out from the shadows. They are no longer just desperate scavengers of the soil. They are the world's new, humble herbivores. You watch as one of them, its fur still a drab, nocturnal brown, nibbles cautiously at a fern frond. This is a revolutionary act. It is the first link in a new food chain. A quirky tidbit of botany is that many modern ferns, like the common bracken fern, are packed with toxins to deter herbivores. It's a quiet testament to the resilience of these early mammals, that they must have rapidly evolved the digestive fortitude to live on this strange, uninviting diet. But the sheer emptiness of it all is what is most striking. This is a world without giants. The ecological niches, the jobs that were once held by the most magnificent creatures the Earth had ever known, are now gaping, vacant positions. The role of large herd-forming grazer, once perfected by Triceratops and Hadrosaurs, is empty. The role of high browser, dominated by sauropods, is empty. The role of armored tank, held by the ankylosaurs, is empty. And most importantly, the role of apex predator is now an unoccupied throne. The planet is a stage, the lights have come back on, but the old cast is gone. And the new actors are still just tiny creatures creeping out from the wings. This is the great silent promise of the early Paleocene. It is a world of immense, unprecedented opportunity. For the first time in 165 million years, the suffocating dominance of the dinosaurs has been broken. For the small, furry creatures that inherited this green, empty world, the possibilities are limitless. But the road back to a rich and complex biosphere will be incredibly long. The mainstream historical fact is that this recovery was not a rapid explosion of life. It would take millions of years for the monotonous fern prairies to slowly give way to the return of true forests, and for the planet's biodiversity to even begin to approach the richness of the world that was lost. The world is alive again, but it is a simple, primitive echo of its former glory. The long, slow process of rebuilding has just begun. The fern prairies were just the first, monotonous chapter of a brand new book. Now, with the stage set and the old tyrants gone, evolution kicks into a gear it hasn't used for 165 million years. For your mammalian ancestors, the age of dinosaurs was a long, dark era of suppression. They were kept small, nocturnal, and terrified, living in a world where the glass ceiling was made of scales and teeth. But with that ceiling shattered, they explode into the vacant world in a frenzy of evolutionary creativity. This is the beginning of the great mammalian radiation, a biological gold rush into the empty ecological real estate left behind. The first attempts to fill these roles are strange, almost clumsy experiments. Evolution, it seems, is throwing everything at the wall to see what sticks. You see some of these bizarre early pioneers scurrying through the undergrowth of the recovering forests. There are the Tyrannosaurs, powerfully built creatures with huge, ever-growing front teeth and massive claws, who likely specialized in digging for roots and tubers. Then there are the Pantodonts, some of the first mammals to achieve any significant size. Imagine a creature like Pantolambda, about the size of a sheep, with a stocky body, 5-toed feet with blunt claws, and a strangely small, primitive brain. This is a mainstream historical fact of the early Paleocene. These first large herbivores were clumsy, slow-witted, and a far cry from the graceful, intelligent grazers, like horses or deer, that would evolve millions of years later. They were the first rough draft of a large mammal, an experiment in scaling up the rodent-like body plan that had worked so well for so long. For the first time in their entire lineage, mammals are getting big. Being small and discreet is no longer the only key to survival. In a world without T-Rex, growing large is now a viable, even advantageous strategy. This radical shift leads to some truly quirky tidbits in the fossil record. Some early herbivores developed incredibly complex and bizarre teeth, like the multituberculates, whose molars had rows of cusps that made them look like tiny, fossilized mountain ranges, perfectly adapted for grinding the tough new vegetation that was beginning to appear. With the rise of the herbivores, it was only a matter of time before the most coveted job in the world opened up: the position of apex predator. The throne of Tyrannosaurus Rex sat empty, and nature was holding auditions. Two main candidates emerged. The first were your own kind, the mammals. Primitive carnivorous mammals known as creodonts began to appear. They were not yet wolves or lions, but something more brutish, with powerful jaws filled with teeth designed for shearing flesh and cracking bone. They were the new hunters in the night, stalking the clumsy, slow-witted pantodonts through the gloom. But they had competition, and it came from the dinosaurs' own surviving children. The second, and far more terrifying, candidate for apex predator was a bird. Not a raptor from the sky, but a monster on the ground. You see it stride out of the trees, and it is a vision from a forgotten nightmare. It is Gastornis, a flightless bird that stood over 6 feet tall. It had a massive, powerfully built body, stout, pillar-like legs, and a head that was almost entirely consumed by a gigantic hooked beak, as brutally effective-looking as a pair of bolt cutters. For a long time, it was assumed this was the terror bird of the Northern Hemisphere, a vicious predator that hunted the early mammals. However, a fascinating scholarly debate now rages over the true nature of this avian giant. The scientific evidence is ambiguous. Its sheer size and terrifying beak certainly suggest a predator, but detailed chemical analysis of its fossilized bones suggests a diet primarily composed of plants. Furthermore, fossilized footprints attributed to it show no sign of sharp talons, the key weaponry of a predatory bird like an eagle. So, paleontologists still argue whether Gastornis was a fearsome killer, a reptilian echo of the past, or a gentle giant, using its formidable beak to crack open giant seeds and tough nuts. Was it the new tyrant king, or the world's most intimidating vegan? The jury is still out. In this strange, experimental new world, the rules are still being written, and the battle for the future of the planet has just begun. While the mammals were conducting their clumsy, brutish experiments on the ground, the dinosaurs' own heirs were launching a dynasty in the sky. The small, beaked birds that had weathered the long, dark winter by cracking open the world's hidden seed bank now emerged into a planet of profound opportunity. Their greatest rivals, the leathery-winged pterosaurs, were completely gone, leaving the planet's airways and coastlines vacant. For the avian survivors, it was as if a continental superhighway, once clogged with competitors, had been completely emptied overnight. They diversified with explosive speed, filling the skies with new sounds and shapes. Nowhere was this evolutionary experiment more dramatic or terrifying than on the continent of South America. For millions of years following the impact, South America was an island, a colossal evolutionary laboratory cut off from the rest of the world. This isolation, a mainstream historical fact, allowed life to take a strange and unique path. On this island, the role of apex predator was not taken by a mammal. It was claimed by the birds, who took the predatory legacy of their theropod ancestors to a horrifying new extreme. Imagine you are standing on the grasslands of Paleocene South America. You see a herd of strange, primitive mammals grazing. Suddenly, they panic and scatter. Striding out of the tall grasses is a creature that seems to have clawed its way out of a prehistoric nightmare. It is a Phorus racid, better known by its chillingly accurate nickname, the terror bird. It stands 10 feet tall, a bipedal engine of muscle and bone, its powerful legs capable of carrying it at speeds rivaling a racehorse. Its wings are tiny, vestigial nubs, useless for flight. But its head is a weapon. It is a massive, skull-like casque, ending in a brutally hooked beak, as sharp and deadly as a medieval battle axe. This was no seed eater. The scientific evidence from their fossils is unequivocal. These were hypercarnivores, the undisputed kings of their continent for millions of years. Scholars still argue whether their hunting technique involved using their powerful legs to kick prey to death, or if they used that terrifying beak to deliver precise, sledgehammer-like blows to the skull of their victims. Either way, for the strange mammals of South America, these hatchet-faced monsters were the new T-Rex. But the terror birds, for all their spectacular ferocity, were an evolutionary side branch, a stunning but ultimately doomed experiment. While they were ruling their isolated kingdom, the quieter, more significant avian revolution was happening everywhere else. The ancestors of all the birds we know today were spreading across the globe, diversifying into a dizzying array of forms. Tiny flitting birds were evolving to hunt the swarms of insects in the recovering forests. Long-legged wading birds were learning to stalk the fish-filled swamps. The first ducks and geese were taking to the waterways. In short, the world was being repopulated by the dinosaurs' children. This is the single most important legacy of the entire Cretaceous period. When you look out your window and see a sparrow on a branch or a pigeon strutting on the sidewalk, you are not looking at a distant relative of the dinosaurs. You are looking at a dinosaur, a highly evolved, miniaturized and feathered dinosaur, but a dinosaur nonetheless. The line is direct and unbroken. They are the last living remnants of the theropod lineage, carrying the genetic fire of creatures like Velociraptor and T-Rex into the modern world. If you doubt this, consider one of the most fascinating and quirky tidbits to come out of modern genetics. Scientists, like the famous paleontologist Jack Horner, have discovered that the genes for ancient traits are often not deleted, but simply switched off over evolutionary time. They found that by manipulating certain proteins in a developing chicken embryo, they could reactivate these dormant ancestral genes. And in doing so, they managed to induce the embryo to grow teeth, not bird teeth, but the curved, conical reptilian teeth of its dinosaur ancestors. They are literally hatching a chickenosaurus. It is a stunning, almost surreal confirmation of an evolutionary truth. The blueprint of the ancient rulers is still hidden, sleeping, inside the humble inhabitants of every barnyard on Earth. The dinosaurs never truly left. They just became smaller, faster, and learned to conquer the sky. While the birds, the dinosaurs' direct descendants, were taking over the skies, another more ancient branch of the reptilian family tree was quietly enjoying a renaissance. These were the survivors who had bet on a different strategy. Not adaptation through rapid change, but sheer, stubborn endurance. You are now looking at the ultimate models of survival, the creatures that treated the apocalypse not as an ending, but as an inconvenient Tuesday. In the muddy, detritus-choked rivers of the New World, a familiar log-like shape floats just beneath the surface. Only its eyes and nostrils break the water. This is a crocodilian, a member of a lineage that had lived alongside the dinosaurs for tens of millions of years, always in their shadow, and has now outlasted them completely. For them, the impact winter was a terrible time, but it was not an insurmountable one. Their cold-blooded ectothermic metabolism was a superpower in a world without food. They could simply shut down, entering a state of brumation, a reptilian form of hibernation, and wait. For months, even a year, they could survive on almost no energy, a feat impossible for the more active dinosaurs. Their freshwater refuge, as we've seen, buffered them from the worst of the acid rain and provided a steady supply of rotting matter that attracted the small fish and invertebrates they could live on. This is the great comeback of the crocs. The scientific evidence is clear in the fossil record. Their lineage sails right across the KPG boundary with relatively few losses. Scientists still debate whether their primary advantage was this incredibly efficient, low-energy metabolism, or if it was simply their choice of habitat. But either way, they are a masterclass in how to survive the end of the world. A quirky tidbit about them is their notoriously robust immune system. In a post-apocalyptic world teeming with bacteria from trillions of decaying organisms, their hyper-aggressive immune response, capable of fighting off infections that would kill almost any other creature, was likely another huge advantage. Alongside them, other familiar reptiles endured. Turtles, with their built-in bomb shelters, simply retracted into their shells and waited out the worst of the fiery rain and acid downpours. Snakes and lizards, small, adaptable, and capable of hiding in deep crevices and burrows, also weathered the storm. For them, the new world was a paradise of opportunity. The ground level, once a terrifying gauntlet patrolled by everything from small, swift raptors to the earth-shaking feet of a T-Rex, was now open territory. They radiated into an incredible diversity of new forms, a silent, slithering conquest of the forest floor. As you look at this new reptilian landscape, you realize how profoundly its character has changed. The Mesozoic era was, without question, the age of ruling reptiles. They were the giants, the kings, the undisputed masters of land, sea, and air. Now that dynasty is shattered. The world is no longer dominated by immense reptilian forms. The age of giants is over. The new reptilian world is one of smaller, more subtle creatures. The kings have been replaced by a diverse, widespread, and resilient populace of survivors. The reptilian grip on the planet has not been lost, but it has transformed from a thundering, tyrannical monarchy into a quiet, sprawling democracy. But nature, it seems, abhors a power vacuum and loves an experiment. About 10 million years after the impact, the planet had recovered and entered a period of intense, sweltering heat. In the hot, humid, swampy rainforests of what is now Colombia, the perfect conditions arose for a reptile to become a giant once more. This brings us to a mind-boggling mainstream historical fact: the evolution of the largest snake the world has ever known, Titanoboa cerehonensis. This was not just a big snake. It was a monster from a fever dream. It grew to over 40 feet in length and weighed more than a ton. It was an aquatic boa, living a life much like a modern anaconda, but on a scale that is difficult to comprehend. It was so large that it hunted and ate the giant crocodiles and turtles that shared its river home. For a few million years, in that sweltering South American jungle, the title of apex predator, the crown once worn by T-Rex, was held by a snake. Titanoboa was the last spectacular echo of the reptilian giants, a final, magnificent gasp of the age that had been so violently swept away. 1 million years. The number is so vast it's almost meaningless, a span of time your mind can't truly hold. But for the Earth, it is a healing balm. You are now standing 1 million years after the day the sun vanished. The planet you see is transformed once again, not back to what it was, but forward into something new. The monotonous green of the fern frontier has finally receded, broken up by the return of true, complex forests. This is a mainstream historical fact of the recovery. The angiosperms, The flowering plants that had just begun their rise in the late Cretaceous have now inherited the earth. The air is filled with the scent of new blossoms and the buzz of pollinating insects. Great forests of conifers, relatives of the ancient trees that were burned away, also stand tall again, creating a deep, dappled shade on the forest floor. The planet is breathing again, its green lungs slowly re-inflating. In the shade of these new forests, the new global drama plays out. You see a creature that is a rough sketch of something familiar, an early primitive hoofed mammal, perhaps a condylarth. It is no bigger than a dog, with a clumsy five-toed gait, but it is the ancestor of all the great grazing herds to come. It browses nervously on the low-hanging leaves, its ears twitching. It is right to be nervous. From the dense undergrowth, a pair of eyes watches it. A creodont, one of the new mammalian predators, is on the hunt. Its body is low-slung and powerful, a brutish combination of a bear and a wolf. The hunt is not the elegant, high-stakes dance of a T-Rex and a Triceratops. It is a scrappy, messy affair, a glimpse into the early, experimental days of the new mammalian world order. The balance of predator and prey has been re-established, but the cast is now entirely, irrevocably mammalian. But the planet's own balance is still deeply unsettled. The impact didn't just wipe the slate clean, it broke the world's thermostat. After the profound, unnatural cold of the impact winter, the Earth's climate began to swing wildly in the opposite direction. A quirky tidbit of paleoclimatology is that the planet, perhaps due to the massive release of carbon from the burning biosphere and subsequent shifts in ocean chemistry, began to heat up dramatically. This culminated, a few million years later, in a period of intense runaway global warming known as the Paleocene-Eocene Thermal Maximum, PETM, where polar regions were once again home to tropical forests and alligators. This wild climate swing from icehouse to hothouse was another immense evolutionary pressure, driving the newly established species to adapt or die all over again. And the scars of the Great Wound remain, a permanent reminder of the violence that birthed this new age. If you could fly over the Yucatan Peninsula, the Chicxulub crater is still there. 1 million years of rain and erosion have softened its edges, and the returning ocean has filled it. But it is still a vast, shallow basin in the bedrock, over 100 miles wide, a raw, visible welt on the skin of the planet. Slowly, year by year, the rivers flowing into the Gulf are burying it under a new blanket of sediment, hiding the evidence of the crime. But deeper in the earth, the true tombstone will last forever. All over the world, the KPG boundary is now a solid line in the rock, a thin parting of dark clay between the chalky white of the Cretaceous and the tan brown of the Paleocene. It is the scientific evidence of the event, a geological scar that will remain for as long as the Earth has continents. Scholars still debate the finer points of the long-term environmental fallout and the exact speed of biodiversity's return, but that thin, dark line is the irrefutable, silent testimony. It is the final, closing punctuation on the 165 million year-long story of the dinosaurs, a permanent memorial to a lost world. For all the certainty with which we can now tell this story, you must understand that for almost the entirety of human history, the end of the dinosaurs was one of the world's greatest and most profound mysteries. Since the first giant fossilized bones were unearthed, people have wondered, where did these titanic creatures go? How could a world so completely dominated by them just end? For centuries, The explanations were rooted in the science and mythology of the time. Early paleontologists, constrained by a religious worldview, often attributed the disappearance to the Great Flood of the Bible. Later, as a more secular science took hold, theories multiplied. Perhaps a great plague swept the globe. Perhaps the newly evolved flowering plants were poisonous and the dinosaurs couldn't adapt. The leading theory for a long time, the mainstream historical fact of its day, was that a slow, gradual climate change, perhaps driven by volcanism or the receding of the inland seas, slowly and inexorably drove them to extinction. The end was seen as a long, sad, drawn-out decline. Then, in the late 1970s, a team of scientists in a rocky gorge near Gubbio, Italy, stumbled upon a clue that would blow the case wide open. The team was led by the father-son duo of Luis Alvarez, a Nobel Prize-winning physicist, and his son Walter, a geologist. They were not studying dinosaurs. They were studying a thin, unassuming layer of dark clay, no thicker than your finger, that separated the limestone of the Cretaceous period from the rock of the Paleogene period that followed. This was the KPG boundary, the tombstone of the dinosaurs. They wanted to know how long it took for that layer of clay to be deposited. To do this, they decided to measure the concentration of the element iridium. This is where the story takes a sharp turn into cosmic detective work. Iridium is a quirky tidbit of geochemistry. It is incredibly rare on the surface of the Earth. Most of our planet's native iridium sank to the core when the Earth was still molten. However, it is quite common in asteroids and comets, which are essentially primordial space dust. The Alvarez's idea was that a slow, steady rain of micrometeorites would dust the Earth with a constant, predictable amount of iridium. By measuring the amount in the clay, they could calculate how many years it represented. But the results that came back from the lab were not just wrong. They were shockingly, impossibly wrong. The clay layer didn't have slightly elevated levels of iridium. It had hundreds of times more than the surrounding rock. It was a massive, global spike. This was the scientific evidence that changed everything. There was no slow, steady process that could account for this. The iridium hadn't rained down. It had been dumped all at once, all over the world. This led the Alvarezes to propose a radical, and at the time, deeply controversial idea in a famous 1980 paper. A 6-mile-wide asteroid had struck the Earth, and the iridium-rich dust from that vaporized asteroid was the primary component of the boundary clay. The dinosaurs, they argued, didn't die in a slow decline. They were murdered in a sudden catastrophic event from space. The scientific community was, for the most part, appalled. Scholars still debate whether the initial resistance was due to a lack of evidence or a deep-seated bias among geologists for uniformitarianism, the idea that Earth's processes are slow and gradual, not sudden and catastrophic. The impact theory was seen as too dramatic, too much like science fiction. The critics all asked the same, valid question. If this giant impact happened, where is the crater? Where is the smoking gun? The hunt was on. And the truly incredible part is that the crater had already been found, decades earlier, by geophysicists from a Mexican state-owned oil company. While surveying the Yucatan Peninsula for oil deposits in the 1950s, they had mapped a bizarre, perfectly symmetrical arc of gravitational anomalies buried miles beneath the surface. They had no idea what it was. But in the early 1990s, armed with the Alvarez's theory and the new evidence of tsunami deposits all around the Gulf of Mexico, scientists put two and two together. They re-examined the old oil surveys and realized that the strange arc was one half of a colossal 110-mile-wide impact crater perfectly matching the age and scale required. They had found the smoking gun. They named it Chicxulub, after a nearby Mayan village. The discovery was a thunderclap in the world of science. It proved that catastrophic extraterrestrial events were not just a possibility. They were a fundamental driver of life's history on our planet, a force that had connected the disparate fields of astronomy, physics, geology, and paleontology into one single, terrifying, and magnificent story. Now, let's bring this immense cosmic story down to the most personal level imaginable. Let's bring it down to you. To do that, you have to look closely at the new forests of the Paleocene, the ones that grew back after the fern frontier. They are noisy, vibrant places, filled with the buzzing of insects and the chatter of the new mammalian world. And high up in the branches, in the dappled light of the canopy, a new kind of drama is unfolding. A small, squirrel-like creature with a long, grasping tail, nimble fingers, and large, forward-facing eyes leaps from one branch to another. This is a primate. This is your ancestor. For the entirety of the age of dinosaurs, the trees were a dangerous place. While the ground was the domain of the great theropods, the canopy had its own set of terrors. There were avian dinosaurs with sharp teeth and claws, and a variety of climbing reptiles. For a small mammal, the arboreal world was a high-wire act with no safety net and plenty of predators. But in the new world, that has all changed. The dinosaurs are gone. The canopy is now open territory, a vast three-dimensional paradise of leaves, fruit, and insects, with far fewer things looking to eat you. It is a world of opportunity, and the primates seize it with all four grasping hands. Their key adaptations, which had been marginal advantages in the old world, now become the superpowers of the new one. Those forward-facing eyes, no longer just for peering through the gloom of the forest floor, are now perfect for judging the distance between branches, for leaping through the canopy with breathtaking accuracy. Those nimble, grasping fingers, once used for snatching insects, are now perfect for holding on to branches, for manipulating fruit, for exploring their world with a tactile sensitivity that few other creatures possess. This is a mainstream historical fact of our own origins. The unique traits that would eventually lead to human intelligence, our binocular vision, our dexterous hands, were first honed not on the savannah, but in the trees of the post-dinosaur world. And so you can draw a single unbroken line through 66 million years of time. A line that starts with that tiny, terrified, shrew-like mammal huddled in its burrow as the world burned. It survives. Its descendants emerge into the fern prairies. Their descendants, in turn, climb into the trees of the new forests, becoming the first primates. Millions of years pass. One branch of that primate family will eventually grow larger, come down from the trees, and stand upright on the African plains. Millions more years will pass, and that upright ape will learn to control fire, to make tools of stone, and eventually to look up at the stars and wonder where it all came from. That creature is you. Your existence is a direct consequence of that rock hitting that specific spot. This leads to one of the most mind-bending thought experiments in all of science. It's a quirky tidbit of speculative evolution, most famously proposed by paleontologist Dale Russell in the 1980s. What if the asteroid had missed? What if the dinosaurs had never been wiped out? Scholars still debate this fascinating question. Would evolution on a dinosaur-dominated planet have eventually led to intelligence? Russell famously created a model of what a sapient dinosaur might look like, the Dinosauroid, a creature evolved from a swift, clever, true-donted dinosaur, with an upright posture, a large brain, and grasping three-fingered hands. Was this the path life on Earth was supposed to take? Would we be living in a world of reptilian scientists and philosophers if a cosmic accident hadn't intervened? Or would the dinosaurs' stable, long-lasting reign have created an evolutionary stasis, a world where intelligence simply never had a chance to arise? We can never know for sure. But it leaves you with a profound and humbling sense of just how contingent your own existence is. You are not the inevitable pinnacle of evolution. You are the product of a cosmic coincidence, the beneficiary of a planetary catastrophe. The reason you are here, listening to this story, is because 66 million years ago, a mountain of rock and ice that had been wandering the solar system for billions of years kept a very specific and very violent appointment with the Earth. The end of their world was not just the beginning of a new one. It was, quite literally, the beginning of you. That profound, humbling, and slightly terrifying realization that your own consciousness is the end result of a planetary-scale game of dodgeball begs an obvious and deeply unsettling question. Is the game still being played? The answer is an unequivocal yes. The solar system was not tidied up after the Cretaceous. The asteroid belt between Mars and Jupiter is still a chaotic river of rock, filled with millions of objects, and it is constantly churning, jostling, and spitting things out into the inner solar system. The Oort cloud, a vast ghostly sphere of icy bodies surrounding our entire system, occasionally sends a long-period comet on a screaming sunward dive. The cosmic shooting gallery is still very much open for business. The threat was not a one-time event. Impacts are a statistical certainty, a fundamental and ongoing process of planetary formation and evolution. But here is the single greatest difference between our time and the time of the dinosaurs. For the first time in the 4.5 billion year history of this planet, one of its species has learned to look up. For the first time, a species has developed the intelligence and the technology to see the threat coming. We are no longer blind targets. We have built telescopes that scan the night sky, cataloging and tracking thousands of near-Earth objects, or NEOS. And even more remarkably, we have begun to practice. This is not science fiction. It is a mainstream historical fact of our modern era. In November of 2021, NASA launched the Double Asteroid Redirection Test, or DART mission. The target was a small binary asteroid system, a larger asteroid named Didymos, and its tiny moonlit companion, Dimorphos. The plan was as simple as it was audacious. Fly a spacecraft the size of a vending machine across millions of miles of space and deliberately smash it into Dimorphos to see if we could nudge its orbit. On September 26, 2022, it worked. The DART spacecraft, traveling at 14,000 miles per hour, slammed into the tiny asteroid. The scientific evidence, gathered by telescopes back on Earth, was stunning and conclusive. The impact shortened Dimorphos's orbit around Didymos by a full 32 minutes, a change far greater than most optimistic predictions. It was the very first time a species had deliberately altered the motion of a celestial body. It was a planetary defense drill, and we passed. To truly appreciate why this is so important, you need a sense of scale. Let's start with an event in our recent memory, the Chelyabinsk meteor of 2013. That was a rock probably no more than 60 feet wide. It never even hit the ground. It exploded in the air miles above the Earth. Yet the shockwave from that airburst was powerful enough to shatter windows across a vast area, injuring more than 1,500 people. Now, let's go back a little further, to 1908. This brings us to the quirky tidbit of the Tunguska event. An object, probably a stony asteroid or a small comet between 150 and 200 feet wide, exploded over a remote region of Siberia. Again, it never made a crater. But the resulting shockwave flattened nearly 800 square miles of forest, an area larger than a major modern city. The mystery of Tunguska endures because no definitive fragments have ever been found, leaving its exact nature a puzzle. Now hold those images in your mind. Chelyabinsk, a pebble that injured thousands. Tunguska, a boulder that flattened a city. The Chicxulub impactor was 6 miles wide. It was not a pebble or a boulder. It was a mountain that hit with the force of millions of nuclear bombs, setting the world on fire and ending an era. The sheer mind-numbing difference in scale is what separates a bad day from a global apocalypse. And so we are left with a new, humbling, and strangely empowering perspective on our place in the cosmos. We are, like the dinosaurs, inhabitants of a beautiful and fragile world that is moving through a sometimes violent cosmic neighborhood. Scientists still argue whether the next significant civilization-altering threat is more likely to come from a stony asteroid, whose orbit we can track and predict with years of warning, or from a long-period comet, a dirty snowball appearing from the blackness of deep space with only months of notice. But the crucial difference is that we are aware, we are watching, we are planning. For the first time, life on Earth is no longer just a passive victim of cosmic chance. We are a species that has finally opened its eyes. As you drift through this long and epic story of destruction and rebirth, a profound lesson begins to crystallize, a truth whispered across 66 million years of silence. It is the great paradoxical lesson of the dinosaurs, the lesson of specialization versus adaptability. Think for a moment about the sheer perfection of the creatures we lost. A Triceratops was a flawless machine for processing tough cycads. Its horned face, its bony frill, its powerful beak, and its complex dental batteries were the result of millions of years of refinement. A Tyrannosaurus rex was the perfect engine for hunting and dismembering giant herbivores. Its size, its bone-crushing bite, its forward-facing eyes, every aspect of its being was exquisitely honed for its role at the top of the Cretaceous food chain. They were the masters of their world because they were perfectly adapted to it. And that perfection was their curse, their very specialization. The source of their undisputed reign became a fatal liability when the rules of the world changed overnight. When the cycads died, the Triceratops's perfect cycad-slicing beak was useless. When the great herds vanished, the T-Rex's immense, fuel-hungry body became an anchor of starvation. They were like master craftsmen who had spent their entire lives forging the perfect key, only to find that in a single, violent instant, the lock they were designed to open had been vaporized. Their success was absolute, but it was also brittle. Now look again at the humble, scurrying victors of this global cataclysm. They were the opposite of perfect. They were the generalists, the scrappy opportunists, the jacks of all trades. The small, shrew-like mammal did not have specialized teeth for eating one kind of plant. It had simple, primitive teeth that could handle a bit of everything. An insect, a worm, a root, a seed. It was a master of nothing, which made it a jack of all emergencies. The crocodile in the river didn't need to hunt every day. Its slow, cold-blooded metabolism allowed it to simply wait, to endure, to survive on a fraction of the fuel needed by an active dinosaur. This is a mainstream historical fact of the extinction. The lineages of crocodiles, alligators, and turtles sail across the KPG boundary with a casual resilience that is almost insulting to the fallen giants. Their strategy was not to dominate, but to endure. And in that lesson, a quiet, challenging echo reaches us in our own time. Does our own complex, interconnected world not resemble, in some ways, the specialized perfection of the Cretaceous? We have built a global civilization of breathtaking intricacy. We have specialized supply chains that bring food from one continent to another with incredible efficiency. We rely on specialized power grids that keep our digital world humming. Our agriculture is often based on vast, specialized monocultures of a single perfect crop. We, too, are masters of our world, perfectly adapted to a specific set of stable conditions. And it leaves you to wonder, in the quiet of the night, how would our brittle, specialized systems fare against a sudden, planetary-scale shock that changed all the rules overnight? But the final and most powerful lesson from this ancient apocalypse is one of hope. It is the lesson of life's sheer, stubborn, and utterly indomitable resilience. The impact was an event that bordered on planetary sterilization. The world was burned, frozen, acidified, and starved. And yet, life did not end. It clung on in the deepest burrows, in the mud of the rivers, in the dormant seeds buried in the soil. The moment the worst was over, it began its patient, inexorable return. The scientific evidence of the fern spike is not just a story of botanical devastation. It is the story of the first responders, the disaster taxa, as ecologists call them. This is the quirky tidbit about the recovery. There is a whole class of organisms that are biologically programmed to thrive on catastrophe. Ecologists and paleontologists still debate whether the astonishing speed of life's initial return was driven more by the incredible hardiness of these few survivors, or by the simple, profound fact that for the first time in eons, the world was a blank slate with absolutely no competition. Life, it seems, does not just find a way, it finds a way, it kicks down the door, and it furiously reclaims any space that has been emptied. From a handful of shivering, terrified survivors in a global graveyard, the entire magnificent, sprawling, and complex biosphere we know today was rebuilt. The planet's heart was broken, but it never for 1 second stopped beating. Let us now fall back through time, back to that final, terrible hour, and witness it not as distant observers, but from the inside. Let's piece together the fragments of the end, a sensory montage of the last moments of the Cretaceous world. For you, the Tyrannosaurus Rex, it begins with a new star. You see it in the bright daytime sky, a searing point of light that defies the natural order. Your hunter's eyes, so perfectly evolved to spot the slightest movement in the undergrowth, are fixed on this celestial wrongness. The deep, instinctual anxiety that has been a low hum in your bones all morning now has a focus. The star grows. The world holds its breath. And then, the universe is torn open by a silent, impossible flash of white. The light is not something you see. It is something you feel. An instantaneous blast of pure energy that sears the landscape into a ghostly afterimage behind your eyes. A moment later, a wave of heat, dry and suffocating, washes over your 7-ton body. And then comes the sound. A physical concussion that travels through the ground and the air. A roar so profound it shakes the marrow in your bones. The sky, which was blue, is now a swirling, angry red. You look up and see a rain of fire, a billion glowing embers streaking down, setting the world ablaze. The very ground beneath your feet heaves and rolls, and your perfect balance, the fulcrum of your power, fails you. You are a king in a kingdom that is dissolving into chaos. High above it all, you, the Quetzalcoatlus, are the sole witness with a god's eye view. Soaring on the thermal drafts, you feel your world of air betray you first. The sky, your home, becomes a chaos of violent, unpredictable currents. You see the fiery streak of the Bolide tear through the atmosphere below you. From your vantage point, you see the curve of the Earth, and you see the point of impact as a blinding, silent starburst on the turquoise sea. You witness the impossible, a hole being punched in the ocean. You see the ejector curtain rising towards you, a crown of incandescent rock and vapor climbing at impossible speed, peeling the sky upwards. The air around you becomes a furnace as the Tektites begin to glow on their upward arc. The heat is unbearable. Your vast, delicate wing membranes, masterpieces of biological engineering, begin to scorch. The atmosphere, now a churning storm of pressure waves from the blast, swats you from the sky like a fly. Your last sensation is one of falling, endlessly, through a sky that has turned from fire to a suffocating, absolute black. Beneath the waves, you, the mosasaur, experience the cataclysm as a series of violent, disorienting blows. The first sign is the light. The water all around you, from the sunlit surface to the deepest gloom, is illuminated by a flash so bright it feels like the sun has plunged into the sea. The shockwave of the impact does not travel to you as a roar, but as a solid, crushing wall of force through the water. It hits your 40-foot body with the force of a physical collision, a deep, bone-jarring boom that ruptures the delicate air-filled sacs of your inner ears. The water, your shield, becomes a conductor of pain. You look up, and the surface of the sea, once a shimmering ceiling of light, is now a chaos of hissing and steam as the first Tektites strike. The sky beyond it is a terrifying, fiery red. The water itself begins to feel wrong, the familiar salinity replaced by a sharp, chemical tang as the first of the acid rain begins to mix with the sea. Then the pressure changes. The entire ocean seems to draw back, and then surges with an irresistible, deep power. It is the Mega-Tsunami, passing not as a wave you ride, but as a colossal, invisible fist that drags you through a world that is now dark, deafening, and poisoned. And in the heart of the earth, you, the small, shrew-like mammal, experience the end of the world as a muffled, terrifying nightmare. Curled in the darkness of your burrow, your universe is one of scent and vibration. The first sign is a tremor, a deep, violent shaking that is unlike any earthquake you have ever known. It is not a brief shudder. It is a continuous, convulsive seizure of the planet. The very soil of your burrow walls hums with a terrifying energy. You hear it as a deep, continuous roar that permeates everything, the sound of a world being ground to dust. The earth above your head becomes intensely hot, the roots of the great trees cooking in the soil. The air in your tunnel becomes thick with the smell of smoke and strange volcanic chemicals. You do not see the flash. You do not see the sky turn to fire. You are blind to the great drama unfolding above. Your entire world is just the shaking earth, the muffled thunder, and the frantic, desperate, and powerful beating of your own tiny, warm-blooded heart. You are a single, flickering candle of life, hidden deep within a hurricane of extinction, waiting for the storm to pass. Close your eyes for a moment. Forget the sight of the giants, the feel of the humid air, and just listen. Try to hear the world we have lost. What was the sound of the Cretaceous? We are a species obsessed with vision, but sound is what truly gives a world its texture, its depth, its sense of life. And thanks to the incredible intersection of fossil evidence and modern physics, we can begin to reconstruct that lost orchestra. The key, remarkably, is in the shape of their skulls. The scientific evidence comes from high-resolution CT scans of dinosaur fossils. When paleontologists scan the skull of a hadrosaur, like a Parasaurolophus, they can map the intricate, winding nasal passages inside its bizarre, hollow, trombone-like crest. They are not just simple tubes for breathing. They are complex, looping, resonating chambers, perfectly designed to produce sound. This is a mainstream historical fact. These crests were essentially built-in musical instruments. Scientists still debate whether their primary function was for this sound production, for visual display to attract mates, or perhaps even as a giant, superpowered nostril to enhance their sense of smell. But the acoustic potential is undeniable. And this leads to an amazing, quirky tidbit of modern science. Researchers have taken these detailed CT scans and used them to create perfect 3D printed models of the internal crest structure. Then, they do something wonderfully simple. They blow air through it. The sound that emerges is not a roar or a shriek. It is a deep, sonorous, almost mournful lowing, a resonant low-frequency hum. Now imagine a whole herd of these creatures, each one with a slightly different sized and shaped crest, communicating with each other across a vast, foggy floodplain. It would have been a chorus of deep, vibrant, almost melodic calls. These were likely just the bass notes of the Cretaceous orchestra. The larger dinosaurs, especially the massive sauropods, may have communicated using infrasound, a sound so deep and powerful it's below the range of our own hearing. Like modern elephants and whales, they could have used these ground-shaking, chest-vibrating frequencies to speak to each other over distances of many miles. You wouldn't have heard it with your ears. You would have felt it in the soles of your feet and the pit of your stomach, a constant, low thrumming that was the very pulse of the living planet. Now add the rest of the symphony. Layer in the higher-pitched sounds, the sharp, bird-like chirps and hisses of the smaller raptors, communicating as they coordinate a hunt, the powerful guttural bellows of a Triceratops, a warning call that was likely a blast of pure, intimidating volume. And perhaps the most famous and most speculative sound of all, the roar of a T-Rex. We don't know what it truly sounded like, but given the sheer size of its chest cavity and the discovery of a syrinx, the vocal organ of birds, in its distant relatives, it was likely not the high-pitched scream of a movie monster. It was probably a deep, chest-rattling boom, a sound of such immense power and volume, it would have been less a noise and more a weapon, capable of paralyzing its prey with sheer terror. And beneath it all, the constant, rich static of a healthy biosphere. the loud, buzzing drone of giant insects, the chorus of primitive frogs and amphibians from the swamps, the rustle of wind through the giant leaves of ferns and cycads, the soft, heavy thump of a dinosaur's footstep on the damp earth. This was the soundscape of the Cretaceous. It was a world saturated with the noise of life, a constant, vibrant, and complex symphony. Now hold that rich, beautiful sound in your mind, and let it fade. In the hours after the impact, the great silence began to fall. The deep, resonant calls of the hadrosaurs were the first to go. Then the infrasonic thrum of the sauropods. Then the bellows of the ceratopsians. The last desperate roars of the predators faded into the freezing darkness. The buzzing of the insects died. The croaking of the frogs ceased. The rustle of the leaves was replaced by the whistle of wind through skeletons. The silence that followed was not just an absence of noise, it was a presence. It was a thick, heavy blanket of death that smothered the planet. The great silence was the true sound of the mass extinction, a deafening planetary quiet that would last for 1,000 years. And so you have inherited a world born from fire and ice. The 66 million years that separate your time from the fall of the dinosaurs have been a long, winding, and unpredictable road. The path from that shivering shrew-like survivor to you was not a straight one. It was a journey through a series of entirely new worlds, each with its own set of rules and its own cast of characters. After the hot, swampy jungles of the Paleocene and Eocene, the planet's thermostat swung again. The Earth began to cool and dry, and a new kind of plant, a humble and revolutionary life form, began its quiet conquest of the globe. Grass. The rise of the great grasslands is the mainstream historical fact that defines the more recent chapters of our age. The dense global forests retreated, replaced by vast open prairies. This new environment demanded a new kind of mammal. You can see the scientific evidence for this evolutionary explosion written in the fossil record. Small, dog-sized, forest-dwelling creatures with multiple toes, like Hyracotherium, were slowly forced out into the open. Over millions of years, in response to the need to spot predators from a distance and run across the hard-packed earth, their legs grew longer, their bodies larger, and their many toes fused into a single, powerful hoof. They became the first horses. In the oceans, another incredible journey was taking place. A lineage of wolf-like, land-dwelling mammals, perhaps driven to hunt in the fertile coastal estuaries, slowly returned to the water. Their legs became flippers, their nostrils migrated to the top of their heads, and their bodies became sleek and powerful. They became the first whales, reclaiming the oceanic throne that had been vacant since the last of the mosasaurs perished. And on the continent of Africa, the cooling, drying climate did something remarkable to your own ancestors. The endless jungle canopy began to break apart, replaced by a mosaic of woodland and savanna. For the primates who lived there, the unbroken highway of branches was gone. They were forced to the ground, to travel across dangerous open spaces. This pressure led to the single most important innovation in your entire lineage: the ability to stand and walk on two legs. Bipedalism. It freed the hands to carry food, to hold tools, and to gesture. It was the crucial first step on the long road that leads from an ape on the savannah to an astronaut in a command module. And that astronaut, looking down from orbit, now sees a world in the grip of another profound, planet-altering event. This brings us to the most difficult and sobering part of our story. We have spent this whole journey exploring the fifth great mass extinction. Now, you must understand that you are alive and listening to this in the middle of the sixth. Scholars still debate whether the total number of extinctions has yet crossed the official threshold to be ranked with the Big Five, but there is no debate about the terrifying trend. The current rate of species loss is estimated to be between 100 and 1,000 times higher than the natural background rate. This time, the cause is not a rock from the sky. It is not a planet-spanning volcanic eruption or a sudden ice age. The cause is a single species. US. We are the asteroid now. The Chicxulub impact was a sudden, explosive event. The sixth extinction is a slow, grinding, insidious one, but the end result is the same. A catastrophic unraveling of the web of life. The firestorm of the KPG event was literal. Our firestorm is the clearing of the Amazon rainforest. The acid rain of the KPG was sulfuric. Our acid rain is carbonic. As the oceans absorb the unprecedented amounts of CO2 we pump into the atmosphere, leading to a new, slow-motion ocean acidification crisis that is once again threatening the shelled creatures at the bottom of the food chain. Here is a quirky tidbit that is also a gut punch of a statistic. If you were to take all the mammals on Earth today and put them on a giant scale, 36% of the weight would be human beings. 60% would be our livestock, our cows, pigs, and sheep. And only 4%, just 4%, would be every wild mammal left on the planet, from the tiniest mouse to the largest blue whale. That is the footprint of our inheritance. We have not just taken our place in the biosphere, we have consumed it. And this is the final, crucial difference between our story and the dinosaurs. The asteroid was a blind, indifferent force of physics. It had no consciousness, no malice, and no choice. It was an accident. We are not. We are, in all the 4.5 billion year history of life on this planet, the first cause of a mass extinction that is aware of what it is doing. We have studied the KPG boundary. We have found the crater. We have read the story in the rocks and understood the warning it contains. The dinosaurs never saw their end coming. We see ours, not as a sudden, unpredictable impact, but as the predictable consequence of our own actions. And that knowledge, that terrible, unique awareness, hands us a responsibility that is as heavy as the world itself. Let's return, for one last time, to the moment that made our world possible. Let's go back to the grey, freezing dawn of the Paleocene. A tiny, shrew-like creature, your ancestor, cautiously emerges from its burrow. It stands, trembling, in a world that is utterly alien. The air is cold and smells of ash and rot. The sky is a featureless, gloomy ceiling, and the world is covered in a monotonous carpet of ferns. But it is alive. It survived. In its tiny, shivering body, it carries the precious, unbroken thread of life, the genetic fire that will, over the next 66 million years, blossom into the entire magnificent, sprawling, and complex age of mammals. It is the beginning of us. This entire epic journey, from the vibrant, sun-drenched kingdom of the dinosaurs to the cold, dark world of the survivors, is not just a story of a random rock hitting a random planet. It is a profound story of endings and beginnings, and how the two are always inextricably linked. The violent, instantaneous death of one world was the necessary precondition for the birth of another. Without the impact, The long, stable reign of the dinosaurs might have continued for millions, even tens of millions, more years. And your ancestors, the mammals, would have remained small, frightened creatures, forever hiding in the shadows of giants. The asteroid was not an evil force. It was a catalyst. It was the great, terrible reset button that shattered a seemingly permanent stasis and allowed for a new and perhaps even more interesting kind of life to finally have its day in the sun. And so, as you prepare to drift off to sleep, look up for a moment, not at your ceiling, but at the imaginary sky above it. The stars and the silent, empty spaces between them are not just distant, twinkling scenery. They are active players in the long and often violent drama of life on Earth. Our planet is not an isolated island. It is part of a vast, interconnected cosmic system, a system that gives life with one hand and, on rare, terrifying occasions, takes it away with the other. The history of the world is written not just in the rocks beneath your feet, but in the orbits of comets and asteroids, far, far above your head. The sheer mind-bending scale of geologic time has a way of making our own lives feel small and fleeting, but perhaps it can also bring a strange kind of comfort. The world changes, continents drift, ice ages come and go, entire dynasties of life rise and fall. An asteroid can cross the sky and erase 165 million years in a single afternoon. The planet endures these immense cyclical rhythms of destruction and creation. And your own small, precious act of falling asleep is a part of that rhythm. It is your own nightly reset, your own small surrender to the vast, quiet cycles of the universe, a tiny echo of the long darkness that gave birth to the morning. And so now, as our long journey through deep time comes to a gentle close, allow the epic scale of it all to soften and dissolve. Let the images of burning skies and titanic beasts fade like a dream upon waking, leaving behind only a quiet sense of wonder. The frantic struggle for survival in that ancient alien world gives way now to the peaceful stillness of your own quiet room. Feel the immense weight of those 66 million years not as a burden, but as a deep and profound foundation beneath you. A story that has led through a million improbable chances to you, resting here now. There are no more earthquakes, only the steady, rhythmic beat of your own heart. There is no more impact winter, only the soft coolness of the air on your skin. The great silence of the lost world is replaced by the gentle, familiar sounds of your own peaceful night. You are a survivor of a story you never had to live, a beneficiary of a catastrophe you never had to witness. And now, all that is left to do is to let go. Let the current of sleep pull you gently away from the shore of wakefulness, out into the calm, quiet, and dreamless ocean of rest. The story is over. A new day will be born, just as it always has.